That was an epic intro, wasn't it, Sam?
It was. Happy Wednesday, everyone. Good
Welcome to
morning.
Code It Live, folks.
Good afternoon, good evening, wherever you are. Welcome to Code It Live. All right. This is the Back to the Future, right, Ed? We are living in the
It
future
is.
with a foot
As long
back
as
in
we
the
don't go
past.
back to 2020, I'm okay.
All right, folks. Welcome to Code It Live. I'm Sam Basu, and this is Ed Charbonneau. We're your hosts for the day. And I see chat room filling up. Hello, everyone. Hello, Ancient Coder. Hello, Aztec. Let's see. Yeah, there you go. Aztec Consulting is here. That's our good friend Ivana in the back rooms. Ancient Coder is here. Yeah, everyone.
Thanks for joining us, folks.
Good afternoon.
We have an
South
amazing
Africa.
show put together for today. It's going to be quite a good agenda of folks to talk about ASP.NET.
So shall we talk about why in the first place, right? So I think like you and me, Ed, we are kind of guilty to this. Like we as technologists, like we always want to be like future facing, right? We always want to talk about the stuff on the cutting edge, bleeding edge stuff. Like you do all things Blazor, right? And
all the time.
And I'm looking ahead at .NET 6 and Maui, and while all of that is cool, it's baking. We sometimes don't stop to smell the roses. Like the present reality is pretty darn fine with the frameworks and the tools that we have, and I think that's the reality for a lot of enterprise apps, right?
Yep, and a lot of folks out there are using ASP.NET, and there is a lot of cool things happening with it that aren't maybe front-end framework dependent things as well. So we've got some folks lined up today to talk about things like minimal APIs and microservices and gRPC, and this is all stuff that has been part of ASP.NET, but maybe hasn't gotten enough of the spotlight.
Yeah. And to your point, like this is all stuff you can use right now with your apps, and they're agnostic. It doesn't care about the rest of your stack. You can use whatever front end, JavaScript or .NET if you want, and then all of this stuff. Like the core part of this, and speaking of core, like ASP.NET Core is a lot of performance, like a lot of fine tuning to really get the most out of your apps. All right, so shall we bring on our first speaker?
We should.
All right, you go ahead and do the honors. Let's see, chat room is filling up here. Hello world. Hello everyone. All right, let's bring on. There we go. Yeah,
there we go.
Awesome.
There we got you.
All right, great. Thank you again for having me on. This is really exciting, and I consider myself an ASP.NET Core developer, so I think it's kind of where I spent the primary bulk of my career. So I'm excited to kind of talk about it and talk about where we're going in the future with it. So it's very cool.
So this way, right? Yeah. Mr. Khalid Abuhakmeh, he's being humble. He's a rock star in the .NET community. So thank you for putting out all the stuff that you do content-wise, Khalid. We really appreciate your blog and your social feeds, and we see how in-depth you go with ASP.NET. So you've been doing this for a while, and you're excited about some of the things that are cooking and that's being used right now.
Yeah, definitely. I think folks are going to get a glimmer into the future and see kind of, the options that they have. And once I start getting into my talk, I think folks will see kind of the strength of ASP.NET Core and, the ability to take all the things that you love and connect it into an ASP.NET Core application. So I'm excited to kind of show some of that today.
Absolutely. Before we start here, Khalid, what are your thoughts on the Back to the Future movie?
So I actually have the Back to the Future hoverboard. I love Back to the Future. I think it's awesome. I would probably say 1 and 2 are the better of the series. 3 is okay, but it starts to get a little campy. But I love Back to the Future. I think it's awesome.
Yeah, 2's my favorite movie of all of them. But if you really take a deep look at all 3, they're kind of all the same movie, which is kind of funny. Yeah. They kind of all start and end the same way, but they're so much fun. Like they're timeless. which is kind of ironic.
Yeah, I would definitely put them in one of the top 3 trilogies of all time. You know, you have Back to the Future, probably Indiana Jones. You probably will throw in Star Wars, probably in there, the first trilogy. So those are probably the top 3 trilogies of all time. So
Don't leave out Terminator, please.
Uh,
Come on now. Come on. Don't hurt my heart.
That's a trilogy. I don't know if that's a thing, but the third one didn't happen. It's all right.
All right, I think chat room is ready for us to get going, and you got some fans here, Khalid, Mahesh.
Oh, wow.
Blogs and content.
Very nice.
So thank you for what you do.
Awesome.
We felt
I'm gonna tap out and let you.
So we're gonna let Ed go for the moment.
Yep. And whoops, I took Sam off, not me.
There you go. All right, love your wall. You got some fans here, Khalid.
Oh, wow. Cool.
On the background, if I may ask real quick, what's some of the pictures?
Oh, so I think this is RoboCop over here. So I'm a big RoboCop fan. I think RoboCop's a cool movie. I think the next one behind me is Guardians of the Galaxy. And then we have Black Panther. And at the end, we have Predator, a Predator poster. So,
nice. All about it.
So, yeah. But yeah, I love custom art. These are like custom prints and stuff like that. So it's kind of nice to do that kind of stuff and support artists.
Yeah, absolutely. Yeah. Very nice. All right, let's get into the thick of things. We are talking ASP.NET. We are talking what you can do right now. I will be your your sidekick that just keeps asking you dumb questions along the way. But we got a good amount of time here. So take us through where do you see minimization? What does minimal API mean? Where does this fit with .NET 6? Can I use this now? And so on. So take it away.
Yeah, if hopefully you can see my screen, correct?
Yes, we do.
Yeah, so I've been doing a lot of research into minimal APIs, especially over the last 4 months, kind of when it started to kind of ramp up, especially with some of the later .NET 6 previews. And today, when you install the Preview 7, I actually have release candidate 1, which is you can get from the .NET GitHub repository, and you can go there and install it. You'll actually notice a dramatic change to the templates, and I'll show you as we go through it. But there's a real effort from the ASP.NET team to kind of reimagine and reevaluate what a default template looks like. And some of these will actually might be shocking even to some folks who maybe are just starting to get into .NET Core and are still maybe stuck on the full framework. These are very dramatically different. So, we already know who I am, but for folks who are joining, my name's Khalid Abuhakmeh. I'm a JetBrains dev advocate, and you can read my blog, and feel free to follow me on Twitter. It's mostly pictures of my dogs and C# tweets. But other than that, yeah, that's me. But like I mentioned, this is really about .NET 6 and where we're going in the future for ASP.NET Core developers. And while ironically we're talking about Back to the Future, the future of .NET is probably closer than you really realize it is. The next release of .NET is going to be in November. Ed and I were talking about this. That's really only 3 months away. And we're getting close to where .NET 6 is starting to get into that release candidate stage where it's essentially feature complete, and the .NET team and the ASP.NET team are just kind of ironing out the bugs in the user experience. So while this is the future, it's not a far off future. And you probably should get to know that this stuff is going to happen. So, and the thing that I've been talking about and will talk about in the rest of this talk is the minimization of ASP.NET Core's templates. Everything is getting very, very minimal, and you'll see what I mean by minimal once we start looking at code samples. So here is the first sample of what a minimal template looks like. Here on the right, we have a minimal console application. And in reality, it's a single line of code. We have console.writeLine, hello world. I actually tweeted about this, and folks who follow me on Twitter will probably have seen this tweet, but take a second and look at this single line of .NET C# code, right? There's a lot of concepts that are essentially hidden from you as a .NET developer. Sam, since you're here, can you potentially name some when you look at the sample? What are some things that maybe stick out that are missing in this essentially one-line application?
Yeah, so this kind of goes back to some of the things you have been saying, like how the future is shaping up while we live in this present. Like, what is missing in this one-line app that you're showing is some of the drama that we are used to with .NET, right? You got nothing. You got like no usings, nothing. Where is program.cs? Where is startup.cs? What's happening?
Yeah, we're missing things like namespaces, using statements, the namespace declaration we normally would have, right? There's no program. There's no entry point. We're static void main. And for that matter, static void main normally takes in command line arguments. Where do those arguments come from? And we're also missing a lot of the curly braces that C# folks are probably used to when programming C# applications. So yeah, like a lot is kind of hidden from you, but this still works, right? Like I think that's the thing that is really like exciting. This still runs. You can see the output down here in the console. Hello World still comes out. So the interesting part of that tweet was, seeing where people kind of fell. Some folks are worried that maybe there's too much magic. And then some folks feel like you said, the drama, the ceremony that comes with setting up a console application is over the top sometimes with .NET. I'd love to see in the chat like how people are reacting or thinking about seeing this right now. And as we go through this talk, you'll see actually more samples and more of these new minimized templates.
So it's interesting. Like you started with templates, and I feel like there's like a balancing act going on. On one side, you have all this coolness coming, and one thing we did learn at Microsoft Build Conference is like C# releases now will coincide with .NET releases, which I think is a good thing. So you have all of these features, and on one side we are trying to lower the barrier to entry, like a college kid who's never done .NET. Why is it so difficult? Why do you need to buy like this heavy piece of machinery? Why do you need to have so much of server and drama before you can write your hello world? So this is great that we are really lowering, but what are you hiding? And maybe maybe you're going to talk about it. Maybe like the templates are the way to kind of guide you through like an easy path, but then not mess with the present that you have. Like you can still do all of the things.
Yeah, I mean, a lot of this stuff is going to be by default in the template. So when you go start new, you will get this kind of experience, but it doesn't detract from your historical understanding of ASP.NET and .NET applications. So if you want to put namespaces back in, if you want to put a program class in and a static void main, obviously all those things will work. I think historically Microsoft has been really a champion about backward compatibility and making sure that, they continue to support folks that maybe can't jump into the future as fast as they would like.
Yeah,
but
and like you have said like this before, like the community has been this has been a little bit of mixed reception, and like our chat room is indicative of what that looks like. Like SMAB UK, hey, good to see you again. There can never be too much magic. So yeah, a lot of people like it. But then some other Manoj BPO7. I love the ceremony. I love the magic, like no magic. I want to know exactly how my app is being bootstrapped. And John Muller here is saying some of the C# upgrades, and maybe we are at 9. We are looking ahead at 10. Some of it is breaking the code, like with some of the implicit using conflicts. So yeah, I'm sure you'll talk more about this, but go ahead.
Yeah. And it's interesting to see kind of the back and forth too in the comments that you just read, because maybe looking at the cynical side of the argument of like, this is just kind of like a grab at folks from other ecosystems to make it easy for folks who are programming in Node.js or in Python, or folks who are new to programming. So there was a recent Visual Studio Magazine article talking to Rich Lander, who is a PM on the .NET team, and they asked him, like, what's your thought on folks thinking that this is just a gimmick to get those folks. And here's his response. And I think it's a decent response. But he says, sure, we do believe that these templates will make it easier to learn C# for folks familiar with Python, JavaScript, or just completely new to programming. Perhaps that's half the reason for the change. The other half is that the current templates, when you start file new and start a new project, the current templates just don't carry their weight right now and are also kind of confusing. I'm guessing he also means for, seasoned professionals, folks with experience. So you can kind of see the .NET team is really trying to experiment with templates to see how they can just make it better for everybody, whether you're new to programming or whether you're, an ASP.NET Core seasoned professional. So, even folks like Damian Edwards or David Fowler, they're not certain that this is the right thing to do, but it's something worth trying to maybe move ASP.NET Core forward and appeal to more people. So,
well said. And you took some good names here. Like, these are great people to follow. If you're in .NET or if you're in ASP.NET, Rich Lander, like, he puts out these amazing, super technical posts on memory and footprint and how things are optimized in .NET. And then Damian Edwards, David Fowler, great engineers to kind of follow on the social media.
Yeah. So this is kind of an interesting debate, and this is kind of the debate I saw on Twitter as well. It's like, you had educators, you had people who potentially maybe haven't looked at ASP.NET for a while. You have folks who are only exclusively doing ASP.NET development. And I think there was a really good debate. But the truth is, it's like, some of this stuff takes a little bit of time to actually use and to kind of formulate your own thoughts and your own opinions. There's always the knee-jerk reaction, the gut reaction when you see something. But in reality, only time will tell if this is actually like a good thing, or if it ultimately, needs to be reevaluated. I think the .NET team sometimes has the advantage of working through these problems and seeing these things for months before anybody else really sees them. So they get to live and absorb and think about these ideas. But for many folks, when they go to install .NET 6 for the first time, they'll see these templates for the first time, and they're going to have a reaction, whether it's positive, negative, or even a shrug. So I'm curious to see what ends up happening in our community once .NET 6 is released. So, the question you brought it up, Sam, which is very good. It's like, this is part of maybe C#9, parts of C#10, but like specifically with ASP.NET Core minimal APIs and the minimization in that console application. How did we get here as a platform as .NET? And here's a non-exhaustive list of things that I could think about that allow the minimal templates and minimal APIs to really work the way they do today. And a lot of those features actually came with C#9 and upcoming in C#10. One of the first things is top-level statements. For folks who aren't familiar with top-level statements, it's the ability to create a file that has little to no ceremony in it. And what that does is in .NET, when you're compiling your application, you can only have one file that is a top-level statement file, and that is determined to be your entry point for your application. But in that specific file, you can leave out, namespaces. You can just kind of drop lines of C#, still in a specific order, but in a way, it almost feels like scripting, right? And top-level statements really allow us, and as we go through this talk, you'll see it in the examples, just allows us to remove a lot of ceremony. Another big feature in C#10 is going to be global and implicit using statements. So I'll show you this once we start getting into the code. But in C#10, we can actually define global namespaces that go into any file. And then those global namespaces will actually be picked up across your application. This kind of allows us to put all the namespaces that we want into a single file, compile it, and remove a lot of that ceremonial namespace additions at the top of files. Implicit usings now allow us, using an MS build task that Microsoft's going to provide, to just generate a common set of namespaces at compile time and inject them into our application. So in a sense, you never actually see these implicit usings. They just happen. And the question people ask, like, well, how does Microsoft or how does .NET know what namespaces people want? For now, from my research, it seems like they've just picked kind of the most common namespaces, things like system collections generic, system task, those kind of things. So right now it's really just handpicked. So there's no like AI or magic behind what namespaces are picked. Records, I think, was introduced in C#9, so it really removes the verbosity of like defining a class and overloading methods for equality, doing things like immutable at compile time checks, that kind of stuff. So records are really a big deal as we kind of try to minimize our code base. Pattern matching, you're going to see in the code sample that I'm going to show later, pattern matching can be used in a way to really reduce the number of lines of code and to do some very neat tricks. Whether people will want to do those in their production code bases, it's really going to be a preference. But pattern matching, I think, is one of the nicer features of modern C#. Source code generators, folks who might not know what that is, now you can add an assembly, and if it has a source code generator, it can add things to your current application. So if you want some data classes and you don't want to define them, but you want to generate them based on some kind of convention, source code generators can do that. Request delegates. I think this is kind of the most interesting addition to like .NET 6. A request delegate is basically a delegate, but it also has the explicit parameter of needing an HTTP context. And this is going to be important. And when we see the code sample that I show, there's an implicit mapping or implicit casting between a request delegate and a delegate. So it allows us to take a normal delegate and turn it into a request delegate to kind of minimize some more ceremony. File scope namespaces. So in C#10, you'll be able to actually define your namespace at the top of the file with a semicolon, removing the curly braces. And then that namespace will actually be the namespace for everything in that particular file. So you no longer have to put, a scope block around your namespaces anymore. Endpoint routing, and there's probably a lot more that I haven't seen. Actually, Stephen Tube released a big article yesterday about .NET 6 performance, and it made me realize, like, as .NET developers, sometimes we take the work that folks do for granted, because that is a huge post. So if you haven't read it, go check it out. It's pretty cool. So
Khalid,
yeah.
can I ask you a question here? So this is all very cool, but what if I am an enterprise developer and I have a business workflow that depends on, like, let's say, a web API project that I've had for years now, right? I don't care about C# 9 or 10. I don't care about .NET 6. Moving forward, will my web API project compile and be able to work the way it did?
Mm-hmm. Yeah, I mean, there's a lot in that question in terms of it depends, especially like what framework, if you're targeting .NET Core. But let's assume you're on .NET Core 2 or 3.
.NET Core.
Yeah. I think it will still work. I mean, it will work. C# is an additive. Every time C# versions itself, it's an additive, version. So it doesn't detract from what's already in the language. It doesn't break anything, for the most part. I mean, sometimes there's like slight breaking changes, but nothing huge, especially if you're just working in ASP.NET. So I think most people can take some of the stuff that I'm showing today, even if they have an existing application, they can start to adopt some of these conventions and these ideas. So it's not like you have to throw away everything and start over. I think that would probably not be the thing I would advise folks do. So yeah, it'll work. I'm pretty confident it'll be fine.
No, I'm with you. There should not be stuff that completely falls apart. But like, I have my present web API project, but post like November, if I'm looking to build another API project, then maybe I should look at some of the newer templates, and maybe you don't even need to think about all of these features, like the language features that you're just bringing in, because the template kind of starts you off from that spot.
Mm-hmm. Yeah, I think, maybe this is reminiscing a little bit, but I still remember the transition between full framework and .NET Core, and the introduction of, the startup class and specific methods for configuring your iService collection and configuring your ASP.NET request pipeline. Those were pretty dramatic at the time, especially when you're coming from, oh man, I'm going to date myself so bad, but when you're coming from your global ASAX file, right? And that's where your web application startup was. It was a pretty dramatic change, but if I was to go back today and work on a full framework application, I think that would feel very draconian. It'd feel very like old and clunky. I think one of the big advantages for me with ASP.NET Core, and I think it's proven to be the right decision, and the best decision for ASP.NET, but it's to try to move as much of like your application's configuration into code, because we used to not do that with full framework because .NET was just a lot slower. So we tried to do everything in the web config. We had like XML configuration everywhere. We had binding redirects. I'm sorry, I should have probably put a trigger warning before mentioning binding redirects. But yeah, right.
And again, like you see Khalid and me and Ed, like, yeah, we're getting a little old, and that's fine. Like, for so Foosh now here in the chat room said Visual Fox Pro, so that is really going back out there. But
folks, I'm still cool in my head. Just humor me.
We have seen things evolve, and it's a good place with what's happening with like the latest transition to .NET 6. The performance tuning part always is exciting because you're getting that much more like juice out of the framework that you're sitting on top of.
Yeah. Yeah. So, like installing .NET 6 and release candidate 1, here are actually the 3 templates that you're going to start with, right? In the top left corner was that first sample that I showed you, that console application template. So if you were to go say start a new project that was a console application, you get this one-liner. In the top right over here, this is our worker service. So for folks who aren't familiar, a worker service is a console application, but it has some of the host building features that come with ASP.NET Core applications. So if you want dependency injection, if you want configuration, so basic configuration from JSON files or environment variables, and if you just want to run some logging comes by default in this worker service template. So if you compare that to the console application, the console application is completely bare bones. There's not really a lot there. The worker service gives you a little bit more, but you can see it's still only technically 3 lines of code. We have our using statement at the top of this file, and then we create our host builder. We add our worker service into the iService collection, and then we build the host and run it. So that should actually be very familiar to folks using ASP.NET Core today with the current templates, because the host builder is normally in your program CS, and it looks very similar to this.
Hey, Khalid, before you go on, so folks in the chat room are saying, like, since you're in slide mode, like some of the text, like the code is difficult to read because it's small. So we'll let you like hop onto like a code editor maybe in a bit and show us some of this. But I did have one quick question for you. So I see the excitement, I see the changes with the template, but what if like in our attempt to kind of lower the barrier and make this easy for everyone, what if I wanted, like some of the things that the chat room was saying, like John Muller and other folks, like if I am to create a web API project today, I have all those CRUD methods, right? I am pointing to a SQL server or an entity framework thing, and I have my read, edit, delete operations, right? So if I start with the minimum API, how difficult is it for me to add those things back so I have full control?
Yeah, I think if those folks can like hold on, we'll actually walk through Damian Edwards, who's been kind to let me use his sample. You'll actually see what a CRUD-like application could be using minimal APIs. So it's possible, and I'll actually show you this as we get through the talk. So
chat room is excited to see you go into code and show us stuff. So
sorry. Yeah, sorry if you can't read it, but the last one is the actual minimal API, like from an ASP.NET Core application. We use this web application class. We call the create builder, which creates a web host builder. Folks doing ASP.NET Core today are probably familiar with that. And then we build that builder, which kind of bakes our iService collection and some of the configuration around ASP.NET Core. And then we can call these map methods. So, if you're familiar with like the Golden 7 HTTP methods, you have, get, post, put, patch, delete, and then options, I think, is one of them as well. But you have most of those. I think patch is the only one that's missing, and that might actually be added. But you just define the method, and then you pass in a delegate or a request delegate. And here's the first time you can actually see the difference between a delegate and a request delegate. This action itself doesn't take any parameters. It's just a basic action that returns a string of hello world. And then we call app.run at the end to start our ASP.NET Core application. So that was a long way to talk about the things that are happening in .NET that affect ASP.NET Core. And all those things are important to understand where minimal APIs and ASP.NET Core are going and what the intention is behind them. Here's an easier code sample to kind of go back to look at it. But I actually turned on Writer's inlay hint so folks could see kind of the types that we're dealing with here. So again, we have the builder. And here's the thing that we talked about that was kind of missing from our console application. Args is there by default. So when you have a top level statement file, your command line arguments are just defaulted into this variable that you have access to. Once we create the builder, we can call build. It creates a web application. And then we can use that web application to map any endpoint that we want. Interestingly enough, you can see that this action, this delegate, the parameter name for map get expects a request delegate. So there's like a cast happening here. Excuse me. Yeah, so 4 lines of code. So if you're thinking about getting into minimal APIs, what does it have? What does it offer? Also, nothing comes for free. So if it has things, it's probably missing a few things, right? So let's go down the list of things that it does have and will have for .NET 6. Routing. You couldn't have an ASP.NET Core application without routing, right? Like you need it. So you have access to all those map methods and ability to set endpoints, register middleware. Remember, this is ASP.NET Core. Nothing's really changed. So if you have middleware and endpoints, those should work and convert over to this pretty okay. You also have Swagger Gen and Open API. So if you're an Open API fan or a Swashbuckle fan, those are things that are going to be supported in ASP.NET Core's minimal API. You also have dependency injection. Dependency injection has really taken a foothold in ASP.NET Core development. You might even argue it's critical to actually running an ASP.NET Core application these days. Like it's almost unavoidable. So dependency injection is a must to make minimal APIs work. There's this new class or type called results. It's actually a return, like it allows you to return an iResult, which is similar to ASP.NET Core's iActionResult. It's similar, but it's different. And I think there's a reason for that. Some of the action results that run through ASP.NET Core MVC's pipeline, like the goal of minimal APIs was to kind of extricate minimal APIs away from the heavy ASP.NET Core MVC pipeline. So you'll see similar concepts in minimal APIs, but realize that they're different and potentially incompatible with some of the things you're used to in ASP.NET Core MVC. There's auth, so the ability to make sure that folks who should be calling your endpoints, clients that should be calling your endpoints, are the people that should be calling your endpoints. And we have mechanisms to run integration tests for our minimal APIs. You know, it's important now to also realize like what's missing. And through my investigation and learning about minimal APIs and just talking to folks, here are some big things that I think are missing that while you can work around them and bring your own approaches to the table, if you're coming from ASP.NET Core MVC, you might be missing these things and might make the transition over to minimal APIs a little bit more difficult. The first thing that's missing is model binding. And I'm not talking about serialization and deserialization of a request and a response. Minimal APIs have that, but they don't have the intricate model binding that's also included in ASP.NET Core MVC. So ASP.NET Core MVC normally has these things called value providers. And those value providers are actually what come together to potentially hydrate an object that your action will have to use or manipulate. Minimal APIs don't do that. They take a much more simplistic approach. There's just some basic rules around trying to pull values from parameters or from a URL path or from the body of a request. So yeah, like don't expect very complex model binding. If you're doing that in ASP.NET Core, like writing your own model binding classes and putting them into the value provider collection that's part of ASP.NET Core MVC, yeah, that's not in minimal APIs. It could be in the future, but it's just not there today. Content negotiation is also a thing that's missing. You'll have to do this manually yourself. What content negotiation is like, if you're a client and you ask the server, hey, please send me JSON back, the server can actually send you JSON back. If you make a request to the same URL, but now ask for XML, in ASP.NET Core MVC, ASP.NET Core MVC would just automatically serialize your response back into XML if you have that, like response type in your ASP.NET Core MVC configuration. With minimal APIs, you're going to have to do this content negotiation yourself. It just you don't get it for free like you do in ASP.NET Core MVC. Validation is another thing. Anyone who's ever done ASP.NET Core MVC or Razor Pages is probably very familiar with that model state class or property that's part of a controller or Razor Page. With minimal APIs, there's no such thing as model state. You're normally dealing with actions and delegates, so there's no base anything within your action. So you have to bring and roll your own validation or pass in your validators through dependency injection. The last thing that's missing, and I could see how people would miss this, but global filters are really a big part of ASP.NET Core MVC and being able to define your request pipeline and to essentially put that, as that one viewer said, that magic. Filters really allow you to create a pipeline. So once you get to your action, you can just deal with the business logic rather than, the minutia of dealing with the request manually, right? Maybe you need to read a header, or maybe you want to automatically kick people out that don't have the right authentication token. You can do that all through global filters. But with minimal APIs, you can't do that. There is a workaround. You can just move a lot of that logic over to middleware. But sometimes, filters have some nice interfaces that I think make writing that code a little easier sometimes. So,
yeah, I think I've used validations in my APIs before. So we'll have to see when that comes back. But like going back to the has list, like I'm a big fan of Swagger actually. Like I come from a client dev experience, like a lot of desktop, a lot of mobile apps that are being fed with web API. It's just like so easy to test. And I'm hoping like you can show us like it's just like one namespace that you bring in and it just turns on Open API.
Yeah. The sample I have from Damien Edwards, and again, thank you to him, has all of the things that I think most developers will want out of their development experience. So you will actually see how Swagger and OpenAPI work. So one of the things that I really I was kind of saying this to you, Sam and Ed, it's like the word minimal as we go into .NET 6 is actually a little bit overloaded. When we talk about minimal APIs, we're talking about those map methods, map get, map post, map, all the other ones. I'm not going to go through them, but what folks might not realize is the minimal mindset, this minimal hosting model actually works with most, if not all, of the existing ASP.NET Core, offerings. So here on the screen, I actually have a minimal web app, and it's hosting my Razor Pages application. So at the top again, we create the builder. And the very next line, we're actually injecting all of our Razor Pages into our iService collection. So it's part of dependency injection. This allows ASP.NET Core to resolve and potentially inject any dependencies into our Razor Pages. So this is really important. After that, we build, and now we have access to our web application. And again, if you're an ASP.NET Core user, you're likely very familiar with how to set up the ASP.NET Core request pipeline. In this case, this code right here, right under the first comment, is likely what you'd see in your configure method in your startup class. So we have that if statement. If we're not in development, then we want to use this exception handler, and we want to use the HSTS for security reasons. And then we have all these additional middlewares for redirection, static files, routing, authorization, and mapping all of our Razor page endpoints. So
Khalid, quick question here. Like this code that you're showing us, this is when you are using Razor Pages on top of .NET 6? Is that what you're showing here?
Yeah. Yep.
Okay.
So yeah, like the minimal approach isn't just about building APIs or building microservices. It's like you can use this hosting model to host really anything that's currently supported in ASP.NET Core today. So you could put MVC in here and it would work, right? So yeah. Does that make sense?
Yeah, no, absolutely.
Okay.
Yep.
All right. So this is a minimal web app. So whenever you hear minimal, it's kind of overloaded a little. So I think when folks hear minimal APIs, I think that's specifically talking about these map methods. So let's jump into the editor. Again, I want to thank Damien Edwards. I asked him if I could use his minimal API playground sample, and he said yes. Hopefully you folks enjoy it. But if you have any complaints, send it to him. No, I'm just joking. Thanks again to Damien Edwards. So
this is being recorded, by the way, folks. So if you need to get hold of it, get hold of this while we are, or at any other point, you can ask questions to Khalid and Damien.
Mm-hmm. So the first thing I want to put a disclaimer out there. So I work at JetBrains. We have the products ReSharper and Rider. We actually don't use Roslyn in terms of using like detecting the language and what version of C# you have. So we're currently only support C# 9. C# 10 is on our roadmap and will probably be out in the next couple months. But you can actually see the big difference between C# 9 and 10 and some of the things that it does in how it kind of like doesn't work with our tooling right now. So if you turn errors on, you can see that there's a lot of things that Rider doesn't recognize as being there. But if I go ahead and I build, you can see we use the actual .NET CLI tooling, and everything succeeds and builds fine. By the way, before I continue, can you folks see this text?
I was going to ask the chat room, let us know if you need Khalid to bump up the fonts a little bit more. Maybe, just for safety, just do 1 point up here, please.
Okay, let me, so I'll do a little writer demo here. So we'll go to preferences and we'll go to editor. And we'll go to font and let's go to 22. There you go.
Yeah, better. Yeah, chat room is saying very good.
So you can kind of see like we don't have the namespaces that would normally come with a web application. And none of this stuff really lights up. Results, like what is that? And yeah, there's just a lot missing. But like I said, when you build, it builds fine. So Damien Edwards wanted to build an ASP.NET Core minimal API example. And I think the motivation that I've seen with a lot of folks dabbling with minimal APIs is try to reduce the number of lines of code, even at the expense of potential readability. Not to say that this isn't readable, but I think most folks, when they're writing their production applications, would lean more towards simpler approaches than some of the examples you'll see here as we go through. So,
yeah, and that's always like it's a fine line, right? The balancing act. One of our good friends, like David Pine, works for Microsoft on the Docs team. Like I have a hard time reading his code. Like it is so concise, where I have to look up the features that he's using. But yeah, it's a balancing act. And before you move on, I had a quick question though. If I were to sit on ASP.NET Core right now, and I'm looking ahead, maybe I want to try out the minimal APIs. How did you arrive here? Like, how did you start the project? Is it .NET New with like a CLI, or is it like the ASP.NET Core with like the empty project?
So I'll tell you how to do it in Writer. You can definitely do this from the command line. Writer uses the command line tooling. So just install the latest SDK. For me, I went to the GitHub page to get like the latest main build of .NET, which is RC1. But you go in here, make sure you have your SDK selected to 6.0. And then you go ahead and you pick the template that you want. In most cases, I usually start with an empty template. And then I just go ahead and hit create. Let's do a new window. So this will take a second as files kind of stream in. This is the curse of screen sharing, by the way. Everything just runs a little slower. And there you have it. So
if you're on Windows, in the chat room, John Motor is saying it does require Visual Studio 2022 Preview 3, which is like the latest bits, new ASP.NET Web application as per usual. But
yeah,
I mean, if you're using CLI, then you can do away with not having the latest IDE.
Yeah, I mean, on Windows, yes, you need, if you're going to use Visual Studio, you will need the latest Visual Studio 2022 Preview 3. You need it because that's the only version of Visual Studio currently that supports C#10, I believe. I know VS Code has C#10 support because it uses language server, the LSP, so it can just work with OmniSharp. And then like Writer and ReSharper will get C#10 support here. It's definitely on our roadmap, but yeah, like
don't use VS for Mac like I do, because that's going through a lot of change as we speak.
Yeah, I mean, I don't use it, so I can't really speak specifically to what's happening in VS Mac. But yeah, that said, again, Writer and ReSharper will use a lot of the .NET tooling, so you can still actually work with it. It's just I would go down here and just turn everything off and just go to the syntax. And again, C#10 and C#9, like C#10 is additive to C#9. So like in this case, let's turn errors back on. There's implicit using namespaces, but if you want to kind of avoid those, you will still get a pretty decent experience as well. And this is my opinion. This is like a editorial thought. while this stuff is fun, mapping from a delegate back to a request delegate, likely it's not something you'll see a lot in day-to-day development. You'll probably end up doing something like this, right? Where you have a path.
Chat room was talking about like magic arguments. Like when you do just a whack and then you're returning a string, I have questions like what is it being mapped? Like, is it just a default endpoint, or are you passing, like, what are you passing into it?
Mm-hmm. So in this case, this is a Lambda expression, an action. So it's not taking any parameters. And actually, let me close this because I think chat will see, and I'll try to explain what's happening in Damien's example, because he really goes through and he like covers all the bases. Actually, let me open his Dapper example, because I think his Dapper example is one that I think will kind of blow people's minds. So Sam, you talked about Swagger, just like you would in an ASP.NET Core application today. You create the builder, you set up your configuration with a connection string. In this case, he's setting up a SQLite connection so he can work locally. But here's where Swagger really comes into play. So
while you're typing, just a quick thing. 425 show just rated us. So thank you, raters. Welcome on board. I will put in the what again. So just so you know what we're doing, we are living back in the future, and we're looking at some of the latest with ASP.NET that's coming down the pipeline while we are still living in ASP.NET Core, and looking at how we can be more productive in the present while we look ahead. So back to you.
Okay, great. So Sam, you asked about Swagger and OpenAPI. So to get that, you will add these endpoints API Explorer. And what this does, it'll actually scan your application and find everything that it thinks is an endpoint. And it'll actually let you traverse through those endpoints and kind of do what you want with that data. And one of those things is to help generate Swagger OpenAPI specification, right? So Damien adds, or we add this Swagger gen. We build our application, and we kind of come to our first interesting kind of line of code here on line 15. This is one of the things I think will be iterated over from the community, but this idea of like, where do you put certain tasks that you want to accomplish during your application startup? This ensure database, if we jump to it, just make sure that SQLite database exists. And we run a database migration and execute it. We end up using the services collection to create a scope, and we find our SQL connection that we defined at the top of our file. But
Hey, Khalid, I got to interrupt for a second. So guess who's lurking in the chat room? It is Damien P. Edwards.
Oh, okay.
Well, hey, Damien, we're just ripping apart your code. Well, Khalid is, and we are trying to understand all of the magic that is implicit.
Yeah. So I think this is one of the first things that will be kind of like debated to death on teams. But this idea of like, how much should you be doing in this program CS, and where should you be putting it? I think here is perfectly fine, but I can definitely see this is going to be something that teams iterate on and have discussions about, and talk about. So on line 15, we just go ahead and ensure that the database exists. And again, we're back into defining the pipeline, the ASP.NET request pipeline. In this case, if we're not in development, we go ahead and set the safe exception handler so that folks don't see our stack traces and stuff like that. Actually, funny enough, since Damien is watching, I'd like to ask, this is the routing middleware, but it only is registered for production, which is confusing to me, because every time I read this, I was like, shouldn't this be like here? But it still works, which is funny enough. But maybe that's just there so that we can handle this error thing, and all these just register themselves fine. But
Yeah, Damien said that's due to a bug. It's a
oh,
workaround.
that is a bug. That's to
Yeah,
work
yeah.
around a bug. Okay, that makes sense.
It'll all go away soon. So this is key because I was going to ask about this. Like, so Damien is saying is not advocating bootstrapping your database connections in your app startup code. This is a self-contained sample, so just the caveat is there, just to see what's happening.
Yeah, I think this is a great sample. I guess to me, I'm like extrapolating to like when teams get their hands on this and start really trying to think about where they should put things and how they should accomplish specific tasks. I think that's where discussions are going to be really interesting on teams. It's not just specifically about bootstrapping a database, but it's about a lot of those discussions that go around this minimal approach. So I'm interested to see kind of how people will formulate their opinions as they start to get their hands on .NET 6. Does that make sense? Yeah. Okay.
Yeah.
So here's our first instance of, here's the error page from here and how it's handled. And I found this really interesting, this exclude from description. I'm assuming this actually keeps it from showing up in the SwaggerGen or the, endpoints API Explorer, because normally this is something that's an exceptional state. It's not something people will ever want to navigate to on purpose, unless they're a developer, but likely not going there on purpose. So this is defined. And then as we continue to define the ASP.NET Core request pipeline, we go ahead and we map Swagger along with its middleware for Swagger UI. Here, we see how a delegate can kind of be cast into a request delegate. And this is probably what chat was kind of like going wild about, right? If we jump to map-get, let's see if I can get to it. Symbols. Yeah, here we go. So if we go to here, we'll see that it actually expects a request delegate. And most folks are probably like, what's a request delegate? If we go ahead and decompile, yeah, that's it. A request delegate is just basically a delegate that takes an HTTP context, right? And that's important in an ASP.NET Core application because the heart of every request response kind of pairing is the HTTP context. So let's go back. On line 35 is kind of where we see the dependency injection and the approach to dependency injection in minimal APIs. And again, since Damien's here, I can just kind of ask him. There seems to be a convention around how parameters for request delegates are resolved. It seems like we look at the iService collection and then potentially look at parameter paths and then look at, say, serializing the body of the request, right? But for all intents and purposes, when folks are using this, they'll have to keep thinking about, okay, where is this data coming from specifically? In this particular endpoint, since it's just getting to-dos, we only ever take in the SQLite connection. We don't take in parameters or any ability to filter right now. So the next one does the same thing. Let's keep going. And here on line 47 is kind of where we see that delineation between a URL part. Here, ID is defined as part of the route, and minimal APIs will take that and actually set this parameter. We also are still getting the database connection from our iService collection. And this is one of the first interesting things that I think like Damien does to really minimize the lines of code. And I think this is where some folks will be like, I love this, or some folks will say, I hate this. I personally like it. I think it's pretty neat, and it's a very neat trick, and I would likely use it. But I could see folks who are just starting to get into pattern matching maybe sticking to if-else statements. But he makes a call to the database, taking the parameter, and then instead of having an if statement to check whether we actually got the value we were expecting, he uses pattern matching. So pattern matching by default will always determine if the object is null or not for you. So he could have even did something like this, but then he wouldn't be able to, create that variable at the end and reuse it. But in this case, we get a return value, and I'm guessing this Dapper method returns null if there's no values returned from the database. And in here, we return an OK.
While you are explaining this, it's funny. So Damien has actually been replying to some of the questions you were posing, which I've been highlighting. But speaking of the usual culprits who bring us all this cool stuff, David Fowler is here in the chat room. Hey, David.
Okay.
So, yeah.
Okay. So I think this to me, this pattern matching approach and trying to minimize the lines of code, I think is very, very neat. The thing folks will see here is just trying to define the OpenAPI Swagger kind of stuff. So we're returning a to-do here, and this particular endpoint may produce a 404 not found. This next method, I think, is probably closer to what most folks will probably program in their own applications. Here we see the first kind of model binding, quote unquote, model binding happening. So if you were to post a JSON that matched our to-do, so if I jump to that, you have an ID, a title, and is complete. Let's see, can I do, where was I? Yeah, back up here. So we have this model binding happening, and we also have the database connection string being passed in through dependency injection. Here is, I believe, Damien Edwards' minimal validation library. Uses data attributes or from the component model namespace. So if you're familiar with data annotations, this library uses that and allows you to do validation. But anyone coming from ASP.NET Core MVC will notice that it's not model state, right? We're not calling model state as valid and getting those errors. So this is something that Damien built himself and brought to the table. Other validation libraries in .NET or ASP.NET include something like Fluent validation. And folks probably looking at this could probably imagine, if they're a Fluent validation user, just passing in the validator as a dependency here, right? And then calling, the validator in the same way that minimal validation calls it. You could also wrap your minimal validation stuff in a factory or a static class like this, and that approach is viable. But I really think the point here is, when you think about validation and using this approach, you might have to kind of reinvent the wheel a little bit. Folks might find that an advantage, and some folks might feel like those decisions could potentially be overwhelming, especially if they're dealing with other things as well. So, yeah, so like I said, I think this is the closest method I think most people will program like. You check the input, you return any problems, validation problems. But by the way, since Damien's here, there's no data annotations in this example, so this usually will blow up. Maybe I should send a PR, but yeah, so we call down to the database, and then we return results created. Yeah, I'm curious from the chat room, like, what are people's thoughts as we kind of walk through this code base?
Yeah, so Khalid, while you're doing that, like you're looking at your screen, we have been highlighting messages that come through. So I actually did have one or two quick questions. Like I saw you use like data annotations up in your namespaces. Like, so going back to Swagger one more time, like you don't need to do anything else to enable Swagger, right?
No. So let's go ahead and run this application, because I think right now we're just looking at code. Oh, but actually, I want to show this, because this is something I actually learned from this code base, which in all my career, I feel kind of silly not realizing it. But Damien goes ahead and executes an update statement and then checks whether the value was 1 or not, meaning, did we actually update a single row from the statement? And then he uses a ternary operator to either return a no content or a not found in the case that we didn't update any, we didn't update any rows, which I thought was kind of like, it's really smart. So since it's here,
but I mean, again, like to the point of like readability, I would have to look up C# features to understand exactly what that did.
Yeah, so let's go ahead and run this example, because I know you keep mentioning OpenAPI, and you'll actually see. So we have our hello world, we have our endpoints, and if I go to Swagger, we can see it here.
There you go. Yeah.
The updated Swagger page and the experience has been really improved. So I'm happy to see some of the newer stuff as well. Some of those method calls that have the types at the end, this is where the schema kind of comes in. So those definitions, let me go back here. Oh, writer. We should quit out of my company chat. But here is where we see kind of those definitions. Let me find the one here. This endpoint produces the to-do. And this is where we see kind of where this schema is coming from. So if you're familiar with ASP.NET Core MVC and API controllers and those produces attributes, those are what those endpoint metadata calls are kind of doing in this case, right? They're just adding those things. This is a different mechanism to add what normally would just be an attribute, right, in your MVC controller. So, yeah. I would really recommend downloading this sample. I think Damien Edwards has done a really great job, and with the focus of like really showing how tight you can get your C# code. I'm curious how many folks will kind of go to this kind of extreme in their code bases, or whether they'll kind of like take their foot off the pedal a little bit and kind of, take more of this approach. As I see more samples in the wild, it's interesting to kind of see the variation in what folks are doing, especially in the space when it comes to minimal APIs.
Yeah, and Damien is saying we hope to remove the need for some of these methods in future by magic.
Mm-hmm.
Yeah, again, like coming from a complete enterprise background of running web API projects, like I see the benefit of how fluent this is. Some of the data annotations, I would say, like still made things like very clear in your mind as compared to some of the request delegates that you're passing in as to what exactly each method is doing. And I wanted to also ask you, like you had mentioned, like the results thing that you could return is kind of similar to like the iAction result that we had. So all of these things are returning results, right?
Yeah. So here's an example of this static class of app results, and they're kind of helper methods, but you can see that it implements the iResult interface, and really the bulk of this happens in the execute async method. So in here is where a lot of kind of, if you're writing your own action result in MVC, it would probably look very similar, if not identical, to a lot of this stuff. The interesting thing too that I found in this sample is that when things get registered as endpoints, they are actually you're capable of generating routes to them through the link generator, which is really nice. And to go back to kind of the things that make ASP.NET Core special to me, and where I feel it's really valuable to a lot of developers, is you don't have to just pick one approach in ASP.NET Core. You can really mix and match things like ASP.NET MVC, minimal APIs, Razor Pages, and there's a fundamental underpinning across all of these approaches that lets you interact with them. Like, I guess sometimes if you were to start like a Vue CLI application or an Angular application or React application, it feels like you have to adopt the entire mantra from the ground up and kind of jump into that entire ecosystem. And I think where ASP.NET Core really shines sometimes is like, it lets you play nicely with all these approaches without throwing everything out that you've worked on before. So does that make sense?
Yeah, no, absolutely. Good points. So on that front, let me ask you a future-facing question, which I don't know if you would be able to answer. Maybe we can ask David or Damon here. So this is what the reality looks like if we did a .NET new empty project with .NET Core 6, right? Mm-hmm. What if, again, I'm old, like no wonder I wear hats on streams, right? If I have a web API project today, going forward in November, how can I not switch to any of this and yet be able to gain C#10, like use some of these features language-wise? Do you know?
Mm-hmm. Yeah, I mean, when you mention you're using like a web API, I imagine you're using ASP.NET Core.
Yeah, exactly.
Yeah. So, I think you can incrementally move towards this approach. The first thing you would likely do is get rid of your, not get rid of, but you would collapse your program CS and startup.cs into each other, into this like top level statement definition, kind of like you have here. I showed that Razor Pages sample. Let me see if I can bring it back up.
No, I mean, I do want to kind of thank you for bringing this up. Like, this is an engaged conversation here, because this is literally how the future is being shaped by the .NET team. Mm-hmm. And I actually do see Ed back in our back channels. Ed, if you want, you can come back on and ask more questions of Khalid, or we can have a conversation here.
Yeah. But I guess to me, it's like if you were trying to port an ASP.NET Core MVC web API, I think the first thing to take advantage of some of this stuff is just really start here and redefine kind of your pipeline, your middleware in this approach, because it gives you an opportunity to kind of take advantage of what's starting to happen with minimal APIs. And this is kind of a good segue, because there's actually a lot of folks starting to look at minimal APIs and try to expand it. And one of those folks that I'm going to give a shout out to is Jonathan Shannon. He's actually reevaluating how his ASP.NET Core library, Carter Libs, which is inspired by like Sinatra, Nancy, how that's going to look in this .NET 6 ASP.NET Core era. And some of the things that maybe are missing today in this minimal API approach, he's trying to fill some of those gaps. So one of the things he's trying to do is reintroduce this concept of modules. Modules are places where you can define your routes in a separate file, or potentially in a different assembly. And yeah, these modules give you a way to kind of register those routes. Some of the other things that he's looking at doing is CONEG, connection negotiation or content negotiation. So he gives you the ability to write your own content negotiators to handle whether you want to return JSON, XML, binary data, and just kind of negotiate based on that header information. And finally, he's reintroducing his own concept of validation, which I'll assume is going to likely use Fluent validation to do that. So here you can kind of see a sample, but definitely follow him, follow Carter Libs on Twitter to kind of see his progress as he goes through this approach.
Yeah. No, these are great points, and I want to kind of bring forth some of the things the chat room is saying, which is all of what we have been talking about, like SMAB UK saying you can use controllers alongside minimal APIs, which was something I was going to ask. And looks like SMAB UK is saying, I've merged the startup and the program and moved some code to minimal APIs. The rest is better as a controller. So again, like nothing has been pushed down your throat. Like you do what is right for your APIs. And this is a funny handle here, the Jesus himself. I find the backlash baffling to minimal APIs because, again, like you have said over and over, like what is being hidden is the implicit part, and you can bring it back. It's just making you more productive with less code that you have to kind of finagle with. It's a lot of things are implicit.
Yeah, it's interesting. Like I can definitely see both sides of the equation, but at the end of the day, it's like, if you're an enterprise developer, how often are you really restarting a project or starting from a template? I'm probably going to guess most enterprise developers who maybe aren't doing like microservices or maybe managing a monolith that's kind of stabilized or kind of like all the infrastructure is basically there. They'll just upgrade to .NET 6 and likely not change any code at all. So this really is likely for folks starting new projects or beginners or folks new to the ecosystem. But again, I think time will tell. It's kind of hard to say how this will all shake out. And like I said earlier, like what Damien said on Twitter was basically, this is something that the ASP.NET team is trying out. They don't know whether it's the right thing, whether time will say it's the wrong thing. Who knows? But I think it's important to try different things and to kind of challenge the status quo. And I think that's really important.
Absolutely. And it's funny you mentioned microservices. We'll post this question to our next speaker as well, which again, the community knows Jimmy Bogard, whom we'll bring on in just a bit. But Khalid, let's have you wrap up here. Any more thoughts around this that you wanted to talk about?
No, I mean, I had one more slide really. This is approach I built around minimal APIs. So one potential criticism of minimal APIs is you might find yourself repeating paths and URL patterns. So I built this NuGet library that allows you to create this branching registration to reduce the amount of times you have to actually register or have to type out, say, that URL path. So this might be something folks are into. This might be something folks are averse to. But it kind of shows you that you can kind of make minimal APIs your thing and build on top of it. And I think that's really important for folks to understand. So other than that, that's really the gist of minimal APIs. If I had to say, should you use minimal APIs? I would say at least give it a try, see if it's something you like. I think time will tell whether it's something that folks will really, be drawn to, or if it's something that's just part of the ASP.NET Core ecosystem. And it's kind of hard to predict what .NET developers want to do. So, but I definitely think you should check it out. It's definitely the future of where ASP.NET Core is going. So,
Yeah, well said. I mean, and David Fowler and other folks in the chat room are agreeing. I mean, this is the right thing to do. And again, nothing has been forced upon us. And I think John Muller here is appreciating your time here, Khalid. This has been great because I mean, you're laying out your heart and soul here. We are all dealing with like very early bits here and staying on the living edge or cutting edge, living on the cutting edge. And some of the tools, some of the ideas, yes, we are trying to see where things settle. But in terms of overall direction and language and how we can cut down on some of the verbose things and have our productivity, I think this is great to stay on top of.
Mm-hmm.
Yeah, this is all fantastic. I think this is something I'll definitely be using in the near future.
Excellent. Yeah.
All right. So Khalid, thank you. Thank you again so much. If you are okay, we're going to bring down your desktop here. Thank you for your time. Yeah, much appreciated. I know you're super busy, but we really, really appreciate. And big shout out to the chat room, John Muller and the Jesus himself, and Damien and David for hanging out with us. We're going to do a quick switch here. So Khalid, we're going to say goodbye to you. Have a good lunch and a good rest of your day.
All right.
So
Thank you, guys.
Khalid.
Thank you so much.
With that, we are ready for the next segment. Yeah.
So we have a good common friend to bring on here, Sam. I think the both of us know Jimmy pretty well. It's my pleasure to introduce him to a new crowd of folks that may not know him, though. So welcome, Jimmy Bogard.
I just think of him as trouble, like wherever.
Trouble. Okay.
It could be a troublemaker, but you know, we need that kind of thing to mix stuff up here and make it. It's no fun without a little bit of a troublemaker. We've got the pit boss, the barbecue expert as well. So there's always that bit.
Pit boss is also like someone in the casinos too, I thought.
Oh yeah. So, pit master. I got to get in with the barbecue terms here, but I know Jim, you're an avid barbecue smoker as well, but also an amazing engineer. You are somebody that I've been following for quite a while in the ASP.NET space, so it's nice to have you here to chat a little bit more about it.
And Jimmy, just so you don't get yourself in too much trouble, Damien is still hanging around.
I got to edit some slides in. Hold on a second.
All right. So I will let the two of you talk microservices, and I'm going to go and grab some lunch and be right back.
All right, Sam, take it easy, my friend. Jimmy, welcome. Let's give you a proper introduction, my friend. Tell us a little bit about yourself and what you're up to.
Okay, sure. My name is Jimmy Bogard. I am an independent consultant, and I'm also a chief architect at Headspring, a consulting company here in town in Austin, Texas. And like for my day job, I mainly, build apps for customers. And usually the apps they want to build they've got some like really big existing, maybe it's called legacy, but this big existing system, and they've had it for decades or whatever. And then it can no longer, it won't go any further. So they need to do something about it. And usually the answer is not, replace it all at once, but replace it in small chunks. And the term of these days of those small chunks is microservices. So I've been doing that kind of thing for most of my career now, of just replacing big systems with smaller, easier to manage systems. It's been fun doing that.
So there's probably some folks out there like, this guy's name sounds familiar, but I can't quite place it. There's a couple really popular open source frameworks that you have on NuGet as well, right?
Yeah. So one of the things I really like to do with my client projects is anything that's not specific to them or like domain specific or kind of proprietary. I try to see if I can re-engineer that into something open source. And so that's really what my open source projects came out of, is trying to solve problems for my clients. And so the couple big ones out there, AutoMapper is of course one that I've invented or inflicted, depending on your opinion. And then Mediator is another one out there that I use quite a bit as well. But I don't know, I've got another dozen or so other ones that are just me trying to solve problems on client projects and then trying to keep using it on the next one, so I can solve problems easier.
Excellent. I've used some of those as well. So thank you for those contributions. So let's, do you have a screen to share with us?
Yeah, let me share
Jimmy?
my.
Yeah, let's get that up. I'm going to hang around and I'm here to chat with or answer questions, but I'll give the floor to you and let you do your thing here. And we've got quite an enthusiastic chat room as well, as you've noticed. We've got some of the ASP.NET team here with us, and it's been a great crowd all morning.
Oh, they can leave now. That's fine.
StreamYard, what are you doing? There we go.
All right.
It's caught up now. There we are.
All right. Well, thanks everyone. Hope everyone can see my screen okay. Sure. Yes. Yes, I can see it. Wow, look at there. Okay. Yeah, so I think we did all the intro stuff. I can skip all that junk. But before we get too far talking about communication and conversation patterns, I did want to kind of level set on the definition of a microservice, because everyone has a different definition of it. And it used to be kind of poorly defined, in my opinion. It used to be defined as a service that is small and does one thing well. And all of those are subjective terms, like what does small mean? What does one thing mean? And what does it mean to do it well? And so I saw a few years ago, there was a survey like InfoQ or something like that. It was like, how big are your microservices in terms of like lines of code or whatever? And there was something like 5 orders of magnitude between like the smallest and the biggest of number of lines of code. So clearly like micro is a totally subjective term. So Sam Newman in his latest book had a much more concise definition that I like a lot better, which is, he defined it as an independently deployable service modeled around a business domain. And the kind of key words here are independent, even though that's still like, what does it mean to be completely independent? Are you like a hermit living in the woods independent? Or are you still kind of interacting with other services around you? And the second part there is that it's modeled around a business domain. And so the idea is that we model our services around the domains and boundaries the business has, so that the software we write is more closely aligned to the kind of natural interactions and business information and functions that we see in the real world. And so when I see people kind of going off the rails, building these kinds of architectures, it's when they've kind of lost that connection with the real world in terms of how the real world interacts and communicates. What I often see times is folks will have kind of a dogmatic approach to microservice building and microservice communication. Things like, we're going to do microservices, but every microservice must be a .NET Core web API. So everything must communicate via HTTP, and everything must be on this one specific platform. And maybe even inside of it, like, it must use domain-driven design, must have all these different patterns in place. And so what they've done is they've adopted a monolithic approach, but just cookie-cuttered the monolithic approach to a bunch of smaller applications and systems. So that doesn't necessarily give them an actual viable end result. So I wanted to take a look and see, people in the real world, in reality, in the meat space. It's a lot messier than the systems that we're building, but we're able to function more or less just fine. And in fact, we've been able to build and manage very complex distributed systems with humans and kind of the real world just fine. So how come the real world is a lot messier and more complex, and they still able to function okay, but when we try to build our systems, we try to make it much more rigid. So I wanted to look at how complex systems work in the real world and see if we can apply some of those same patterns and designs to systems we might write. So in the real world, messaging can be a lot more complex than we find in our systems. There's different communication mechanisms we choose for different situations, different communication styles, and so we kind of mix and match and choose the one that's really best suited for each job. And we find that those communication patterns will be able to work in the real world, then I tend to find that those same patterns, communication styles will work in the systems we build as well. And so I wanted to take kind of an example of, what is a complex distributed system we see before the age of computers, before we had electronic communications, and how can we apply those same kinds of principles for those kind of older ways of doing things to newer applications and computing-based systems for us. So I live in Austin, Texas, and it's a bit of a hipster town. And one of the things that we have in our town are these things called food trucks. And food trucks, another thing that we've gentrified, is this idea to have a restaurant completely on wheels. So everything that needs to happen in order to be able to transact business is on this one single physical truck. And we have, we used to anyway, when in the before times when we had offices and such, we had a food truck that would come. There was just one single guy, and that one single person did every single task that needed to be done in order to transact business. And everything was synchronous. So like you would go up to the counter, you would order something, and you wouldn't physically leave the counter until you've received your food. So everything was more or less kind of in process. So you'd have one person coming at a time in this one single line, coming up to that person, ordering. They would go make the thing, they would pack it up, and they'd give it to you. And then when you got the food, you would leave, and then the next person would come up. And so this sounds like very familiar to our kind of interior sort of architectures. We have a single thread of execution. I know async await and IO kind of changes things a little bit, but essentially the person making the request, the person in the browser clicking the button, they're sitting there and waiting for a response to come back before they go on and do something else. Like they're staring at the screen, maybe they got a fancy spinner or something, but they're not doing anything else until they receive the response and go on to do something else. So these food trucks, they're pretty expensive to build and they're pretty expensive to operate. So if you are going to build one of these things and start to operate it and make it a business, you have to create that business plan that says, here's how much money I can make in a given amount of time and be able to be profitable. And one of the kind of the critical things for you to figure out is like how much money can you take in a given amount of time. And you have a certain level of sort of levers for that. You have like, well, how much do I charge for the food? What are the expensive items versus the cheap items? What are the items that have a higher margin versus a lower margin? One of the critical things you have is how many orders can you process in a given amount of time? And the more orders you can process, then the more money you can make. So if I'm here in my food truck, I can just lay out the set of steps. Maybe I can practice at home to see what it would take, but I can kind of figure out a rough guess to say, here's the average number of orders I can process in a given amount of time. And I can do that by breaking down each step and kind of timing to see how long each one takes. So I could say on average, step one, taking your order and taking your money, that's about 30 seconds. To dress up your thing, it's like get the ingredients ready, that's 10 seconds. I guess I'm fast. To grill the items that you have, to cook them, that's 100 seconds. Finally, to pack them up is another 10 seconds, and to hand them to the customer. So adding all this up, this is 150 seconds. I just completely made up, mainly for the math purposes, to say that the maximum number of orders I can take in an hour is 24. Then I can say, well, how much should I charge for each set of items based on, kind of what people around me are typically charging. And that should give me a rough understanding of kind of what's a maximum amount of money and revenue I can take in a given day. And I can work back to see if that's profitable. However, if I just took this kind of naive model and put it into practice, I would find that I never get close to this theoretical maximum of the number of orders I can process in an hour. And the reason why is that the real world is not this clean. We don't just have like people coming in every 2.5 minutes to be able to get their food. We have problems like, one, people don't like lines. At least in the States, they don't. Sometimes I give this talk in England and they are perfectly happy with lines. But generally, people don't enjoy waiting in lines. And so if I'm coming up and I see that there's a long line, people tend to just walk away. They say, oh, there's 10 people in this line. And from historical experience, I know that, it takes, 3 to 5 minutes per person. I can add up the number of people and multiply it out, and they're like, I don't want to wait here a half an hour for my food. Another thing that's kind of messy is we can't assume a constant rate of flow. So in our office, we would do things like at certain times of the day, like 11:30 or 12 o'clock or 12:30, we'd get in our company Slack and say, hey, who wants to make a food truck run? And then a group of 10 of us would go down and arrive all at once. So it was not like one person arriving every 2.5 minutes. Instead, you have these kind of big groups of people that come up at once that would give the appearance of a really long line at certain times a day. So if I'm this person that's coming by and says, sees this really long line, I might just assume that it's going to take absolutely forever for me to get my food, and then I'll just move on and go on to something else. Maybe order Jimmy John's or something that's fast. But if I'm this restaurant owner in the counter at the cash register and I see someone coming up and this look at the line, have this dejected look on their face, and then walk away, I'm like, oh no, that was just lost money, lost revenue that person intended to purchase, but they didn't because my response time was too slow. And there are some rather famous papers and analysis from real world e-commerce sites that measured this. So I think Amazon is something like I'm making all this up, was like every 10 milliseconds of extra latency was like another $1 million of sales lost. That was probably not the right numbers, but they basically were able to measure that to say the slower we are, the more people get frustrated and will leave to do something else and not come back. And when I was on an e-commerce.com application team, our bonuses are actually tied to that, of like how quick was our website, how many people started the checkout process and stayed with it versus how many people abandoned the checkout process after they already started. And so this is, if I'm the business owner here, what I'm really trying to do is maximize the number of orders I can take in a given amount of time. And so I would like to tweak my business process to be able to optimize that metric. Now, one thing we could do is just say, okay, if I want to double the number of orders per hour, why not just have a second food truck? Just copy paste the food truck and say, instead of having one food truck, we'll have 2 food trucks. So now we can take twice as many orders. And we can do that. I rarely see it done, right? You don't really see like 2 McDonald's right next to each other. Although some places in Seattle, there's like a Starbucks on every single corner. So maybe that's not a great example. But you're not really going to see.
I can attest to that. I've been there.
I know, it's sad. So you really that's a very expensive thing to do because every single restaurant has a certain amount of overhead to be able to get the real estate and licenses and all that sort of stuff. That's not really what you see happen. Is they don't try to just kind of copy and paste the entire operation. Instead, what they'll try to do is try to optimize the overall business process as is in that same location versus just kind of scaling up and scaling up and up and up. So how do we fix this? Well, what you typically see is not restaurants being staffed by one person, one very frustrated, stressed person. Instead, what we would do is hire more workers and specialize what each worker does. So instead of us having like just one person doing every job, each person would do one specialized job. And when I have one person doing one individual job, we find that they can optimize their work based on their overall or their specific set of needs and the kind of their constraints and whatever work that they're doing. We also can see that we can start, for some of these stations, we can actually start several orders in parallel. So think about something like grilling. I can buy a bigger grill that can grill more things at once, and I can put down more things at once. Maybe I can still only take one order at a time, but I can start multiple orders at a time to have them all come out and be done in parallel there. So if I'm able to do this, where I'm trying to optimize the number of orders I can process an hour, it turns out that what I really want to optimize here is the number of orders I can take in an hour. Because once you have placed your order and given the cashier money, you're much more likely to stick around and actually receive your orders. You might be waiting a while, but I've got your money now, so it's going to be much harder for me to give it back to you. So at this point, ordering is the only bottleneck in my system now. And so if we went back to those other set of made up numbers, I think it said like ordering takes 30 seconds per person. So now theoretically, I've gone from 24 orders per hour up to 120 potential orders per hour because Now ordering is my true bottleneck. Now this is easier said than done. We can just say hire more people and then call it a day. But now we've introduced the problem of needing to coordinate this work. And so now it becomes complicated of how do we actually fulfill an order? Because before, I, as the single owner of the store, had the responsibility of doing every single job. And so I didn't have to talk to anyone else to be able to do my job. But now I've got other people doing individual jobs, individual steps in this process. And so how do I coordinate this overall activity of completing the overall business transaction, which is getting my order? So our transaction is no longer synchronous. So I'm not like the person, the customer, no longer sits at the front of the cashier waiting for their food to come around. Like they're not just standing there for the entire operation. They've moved on and done other things by now. We also have to figure out how do later steps know what to do. So how does the grill person know what to grill? How does the dress person know what to dress? How does the pack person know how to pack these things together? All these things kind of need to know how to do their step of the job. And finally, how do we know when we're done? So how does the pack person know that the order is complete and it's able to be then given off to the customer? And so the solution here is going to be messaging and communication and conversation patterns. Now, there are, at least in the States here, there are some pretty awesome reality shows around like restaurants and bars that highlight dysfunctional restaurants and bars. And one of my favorite ones is this one called Bar Rescue. And like inevitably, the problem is always the same. They have poor communication. They're not writing down the orders, or they don't have an agreed upon protocol about how do they take orders and accept orders and fulfill orders. I mean, sometimes it's the bartender is like pouring drinks too big and giving his friends free drinks and like taking money out of the till, things like that. But usually it's a problem of communication. And so what the blowhard host typically does is it implements communication patterns and protocols and said, we're going to agree together about how do we take orders, how do we fulfill orders, how do we deliver orders. And if we get a good system together about how to do that, then everything's going to run much more smoothly. And so that's exactly what we need to do here as well, is look at each of these interactions and figure out what is the most appropriate communication mechanism between each of these interactions and say, this is the right one for this specific job, or this one is the right one for that specific job. So let's look at the first one, which is placing the order. I need some information from the customer, which is what food do you want? I also need to know how to notify that the customer that the order is ready. And then typically what we see in this interaction is that it's a synchronous interaction. So the cashier and customer are blocked during this interaction. So you imagine yourself going up to a restaurant or going to get some coffee or fast food or whatever. When you go up to the cashier, it is a synchronous interaction that you have. So you're talking to the cashier, they're talking to you, and neither of you are doing anything else while this interaction is happening. And so there's a reason why we have a synchronous communication there, is that it's very low latency. So I can go back and forth very quickly to tell them what I want. They tell me what, they validate what I want. And so we can have a very quick back and forth to be able to get that order. And so by having a synchronous interaction, it ensures that it's a very quick operation, and that can then optimize the number of orders I can process an hour. We also typically see that order or that communication is non-durable. That is, I don't write down my order and then like pass it over to the cashier, have them read it, and then write a note on it and then pass it back again. Instead, it's completely non-durable because it's verbal, so no one is actually writing anything down. Now, for online ordering, that's a bit different, so I'll kind of ignore the asynchronous aspect of it. But we do find that, like generally, I tend to prefer this initial operation to be much lower latency and quicker to get a response back, because I want to know very quickly, you've received and processed my order. If everything is asynchronous, I have to send an email and wait for a response. Well, I'm still getting hungry. I don't know when my food is coming, so I want to have that that very quick response to tell me, yes, we've got your order, everything's good, and you're going to get your food soon. So in the virtual world, what maps to a synchronous, non-durable communication? Well, this would be most appropriate for web services or APIs. So like a web API is synchronous. So a client makes a request and they're waiting for a response. It's also non-durable. So like nothing is writing down this information as it goes. Like it just lives, it lives like in the communication path as it goes, but it's stateless. So we're not having to have the extra overhead of each step in the process durably writing to disk somewhere to be able to pass it on to the next step in the process. So an API could look something like this, where I post up my order information, the things I want. So Jimmy needs a taco, and the cashier or the server responds back immediately saying, yes, I've received your order and I've created it, and you can find the order at this location. Again, this is completely made up interactions, but seems to make sense to me. So what patterns do we see here? This is a synchronous communication, and it's also request response. I make a request to a server, and synchronously they give me a response back. So that was the easy one. Like generally, when we're building applications, it typically starts out with a synchronous request and response. Like 99% of the things I build are still web apps that have a synchronous interaction from the end user, which is the user clicks a button or clicks a link, and they wait to get a response from the server. But for more complex business processes, we can't achieve everything in the context of a single button click. The same thing here, the user is not going to wait there. The customer is not going to wait at the cashier for all the back-end steps to process. Instead, those are going to be happening offline. So how do we manage that? Do we make these communications durable or non-durable? Who's really the person in charge of the entity in charge of managing the different steps in the process? And if something goes wrong, how do we manage those failures? In a synchronous transaction, if I just connected everything with APIs, for example, then I get immediate feedback. So I call an API, calls an API, calls an API. Well, that thing throws an exception or has some failure, that will bubble back up into the very top level API call. But there's a problem there that if any one of those calls fails, it could cause the entire operation to fail, which is not necessarily what we want to have happen. So let's look at this first one. If I chose a synchronous request response, it would be analogous to a web API call. So I could say, okay, now that I've called the cashier to say post the order, then the order person can post a message or post a request to the dress person that says, I need you to dress this order, and here's a reference to the information of that order. And the dress person says, got it, okay, here we go. I got it, good to go. Now, in the real world, this would look like when the customer comes up to the cashier, says your order, when they've successfully paid, the cashier would then turn around and then yell at the dress person, order up, order 23. Now, I have seen that in restaurants. Like we hear a lot of yelling of people kind of yelling at each other what to do. But having actually worked in those environments, it's extremely stressful because you have to be like, your listening ears have to be on the entire time, because you have to make sure you get these messages. Because if you don't get them, it's not durable. No one's written it down. And so if you didn't listen, if you didn't hear, then we don't get that guaranteed response. So in this case, like, well, what if I yelled out to the dress person and said, order up, order 23, got it. All right, order up 24, and I didn't get a response. So did they hear me and they didn't acknowledge, or they didn't hear me and they're just busy doing something else? And so it could be just like, no, it's just, the dress person's busy doing something else. They didn't hear me. Or it could be like my toddler, that he hears everything, but never acknowledges anything. And so it could be that they heard me, but they just, they're busy doing something else. It's going to take them a while to acknowledge. So they're like, hold on, I'm doing something. Okay, yes, I got it. And they go back and doing their thing. So the synchronous request response, you have this problem that the client is waiting for the server to receive a response. And it could be that, they're doing something else. So like I'm overloaded with work. I'm so busy that I just return back a 503 saying I'm too busy. And so the client's like, well, I still need to process this order. So let me go ahead and just try again. Okay, let me just retry that operation. And we have libraries that can help us do this, right? Like I use Poly quite a bit to be able to do exactly this, to have some kind of retry. And so, yes, so I can call again. And so, now they're not busy. Now they can do it. and be able to process that order. There's a problem here, though. They might have actually heard me the first time, but I just didn't wait long enough for an acknowledgement. I said, order up number 24, and they were just busy doing something. And they heard me, but they're like, okay, I'm just keeping in my head. Hold on, I'm almost done. And then, okay, now I'm done. I got it. But if I get another request for the same order, I need to make sure, like, I, as the dress person, don't see this as a separate order. That's the same order they had before. So I'd have to make sure that my server, in this kind of stateless communication, this stateless synchronous non-durable communication, I would need to know how to make sure that if I get 2 requests in or to do some work, that are these the same requests or are these different requests? So if I'm going with a non-durable way of communicating, I might have to put that kind of idempotency and exactly what's processing on the server side. Now, there are ways of approaching this and ways of doing this, but in general, I find that this kind of like everything communicating via non-durable synchronous communication can work with like limited number of people, right? But as soon as you start to get more and more people involved, it becomes way, way harder to be able to have these kind of coordinated communications going on. You got this kind of game of telephone going on. You have to make sure that everyone's up and available and is listening at the same time. You almost have to have like, I don't know, therapy style things where only one person can talk at once to make sure no one overtalks each other. It just becomes much more complicated. So one thing we can do here is say, you know what, instead of whenever you tell me to do something, instead of me doing it right away, I can actually just write it down on my side, and then I'll just say, I'm not doing it right now. I've just received your request. I'm going to do it sometime in the future. And so HTTP does have this kind of baked into its protocol. I can return back an accepted response, which is just to say, yep, I got your request. I'm not doing it right now. I'll do it in the future, but I did get your request. And so this could be a way for us to kind of offload some of the processing, but we still have the issue of, well, we're not doing the work right now. We're doing it sometime in the future. So we still have to have some way to coordinate this kind of async processing in the back end. So in that kind of the bar rescue shows and the kitchen nightmares sort of shows, one of the things they introduce is people just writing stuff down. Like instead of yelling at everybody what to do all the time, instead you just write things down. And now you can always have something to go back to, be able to say, okay, yes, you told me to do something, but now I've got like physical way for me to go back to. And if I forget something, I don't have to go back to you to get the information. I can go back to this pre-agreed upon information that can live a lot longer than just a simple conversation. And you can actually physically see this in the restaurants that you can go to. Like this is an example of a burger joint here in town called Mighty Fine. And one of the really cool things about what they do is they have like all the order information in the same thing, in the same container that's going to hold your food as well. So when you walk up to the counter, instead of putting information in a computer, what they're doing is actually writing all the information down on the actual bag itself. So they'll do things like, okay, do you want a hamburger or do you want a hot dog? And so they'll circle that there. What do you want in your hamburger? And so you'll say, this person says they wanted ketchup, cheese, and that's it. Just cheese and ketchup and French fries. That's kind of a boring burger, Vanessa. And so they circle their ingredients. And what that is doing then is recording their choices so that later steps can be able to see their choices and not have to go back to Vanessa to be able to get that information. So this bag then actually flows through each step of the process, one by one, each step doing one specific part and fulfilling each step until it finally arrives at the end to be delivered to the end user, which is the end customer, which here would be Vanessa. And so this kind of flow, where it's kind of one-way unidirectional and very well known up front, is actually known as a routing slip. And a routing slip, what we'll do is in the initial message that contains all the information about the order, I will also include all the steps needed to process that order. And that those steps then are the instructions for each of the different processes to know what to do next. So in this case, I create a durable message. So it's like an actual physical message. Like in the case of real world, it was a bag. And that bag contains the order information, but also includes information about what are all the different steps in the process. So in the bag, for example, you can see it was circled French fries. When I circle French fries, I know it should go to the fry station after the burger station. So the bag goes to one step, the step does their work, that employee then looks at the next step in the process, or in this case, the worker or microservice, looks at the next step of the process and forward that message on to the next step. The next step does their work on that, whatever it is, looks at the message and said, okay, what's the next step after me? And forwards it on to the next one. So we can upfront decide what are all the different steps in the process. So if there's no grill step in one, or there's no like drink step in one, then we can just remove that step from the set of instructions and not have to have each individual step make decisions about where should this go next. The next thing that's interesting about this is it could be completely nonverbal. So that bag can flow from step to step to step without anyone having to talk to each other. There's no kind of synchronous communication that happens between each different step. So each step then, instead of relying on someone telling them what to do, instead relies on a queue to represent the backlog of work that they have to do for that individual station. When I want to indicate or tell the next step in the process to do some work, I don't have to get their attention and say, hey, George, hey, I need to do the next set of work. Instead, all I need to do is just place the message in their queue or place the bag at their station. And that's the communication to them that they need to do that next set of work. But there's no acknowledgement that needs to happen. I just need to make sure that I make it over to their station with the bag. And as long as I make it over to the station with the bag, as long as I can successfully do that, I can deliver the bag to their station, then my work is done. I can trust that station to be able to manage their own work and be able to fulfill their step and move it on to the next step in the process. So what this gives us is with this asynchronous communication now, that I'm not waiting for acknowledgments for other steps. And by writing messages down, having durability associated with them, that allows me to decouple each individual step and station temporally, meaning I don't have to now know, I don't have to worry about the timing of each step in the process. I only need to worry about my station, and then once I'm done, I can just forward on to the next one. So with this, we still have our independence of our microservices maintained. Like I do my one job, I manage it myself, I optimize my step for the whole, but we still are able to fulfill this overall business process. Now, this works for like simple processes, but in the businesses that I work with, nothing is ever as simple as just like a simple assembly line of like one step, next step, next step, next step. Instead, there's always like customizations. And so if you looked at how fast food restaurants worked 40 years ago or so, they were like this. Like they were just assembly lines, factories of just pumping these things out as quickly as possible. But over time, customers would start to get more sophisticated and said, I don't want the same burger every single week. I don't like onions on mine. I want something else. And so as soon as you started introducing variability into the process, we couldn't have just this very simple assembly line set of work. So let's turn this up to 11 and see like how do real world chains work. And I can speak from experience because I actually worked at a more complex fast food restaurant in Whataburger here in Texas for a number of years. So I know how it actually works behind the scenes. And they don't work like, at least this one, Whataburger doesn't work like this, or McDonald's. They don't work in this like very assembly line way of working anymore. Some restaurants do, because you can imagine like your Five Guys, the ones that have like a very simplified menu, they can have this more simplified processing behind the scenes, but McDonald's doesn't do this anymore. They don't have an assembly line anymore. They have a much more complex way of coordinating the orders. So if I look at something like McDonald's, it has more stations. I don't even represent them here, but there's also the ice cream station that is broken half the time. They've got like fresh salad station that I guess people still use and order stuff from. Even the frying station is more complex. Like they'll separate out meat and vegetables. And even further there, if they're doing, if it's during Lent and they got fish, they'll actually separate fish from chicken because you don't want to mix those two. They'll make each other taste gross. So it starts to become much more complicated and to being able to manage these kind of orders, but they still want to deliver in the same speed that they used to. So in this case, now I have many steps being independent from each other. So they can be done in parallel. They can be done completely independent of each other, but not all of them, right? Some actually do have a dependency. Like if I ordered crispy chicken sandwich. Well, the crispy chicken is fried, so my dress station that is going to put the burger together has dependency on the fry station to get its work done. So I need to have some coordination there. But some things are independent. Like, do drinks ever depend on fries? I mean, I guess I used to dip my fries in the Frosties at Wendy's, but that's about it. Like, there's not actually, from the business perspective, like dependencies between some of these stations. So it's not necessarily possible to say, from a given order, these are the exact set of steps that need to happen in order to fulfill this order. It might be something that really I need to let independent stations work independently of each other, and the ones that need to coordinate do need to coordinate with each other. And then we also find that the orders themselves are much more complex. Like, I can take things off, I can add things on. Like, some people will do things like, I want my burger well done. When I cut in half, the bun's toasted on both sides. All these kind of more crazy options available to us because we're, what was her motto? It's have it your way. Yes. So now you can, instead of like every burger being cookie cutter, you can customize your own individual order. So now, how do we manage this? How do we ensure that when an order comes in, it comes in and gets processed quickly, and it's still delivered within a reasonable amount of time, which I think for McDonald's is like 5 minutes or less is what they're targeting. So how do we have a much more complex back-end coordination and not have everyone, like throttling each other in fistfights by the end because they're all yelling at each other trying to get the order done. So let's do the same exercise. Let's look at these one by one and see, based on the kinds of things I'm coordinating, what makes the most sense. Now, taking the order is most likely still going to be a synchronous operation because still that's like the best experience for the customer. It also does, if I'm talking to a human, it also has a higher likelihood of success. So by talking to another human being, if like my credit card didn't work or something, they'll be like, oh, do you have another one? Or if I don't have enough change, and be like, don't worry about it. It's just a couple pennies. But what I'm trying to do here is have a very quick operation that's a very high likelihood of success. This also means that, again, that while I'm taking their order, I'm writing it down on my side. And then when we're finally done, then I go ahead and place the order and put it in the back end, or kick the back end processes off. So I still have a synchronous, non-durable communication between the cashier and the customer. But once that's done, once I've taken the order and once I've paid for it, now it becomes a complicated thing of like, well, then how do I then process the order? Well, we saw from our last example, there was a simple business process that synchronous communication is just not tenable. Maybe you still see like McDonald's people talking to each other, but that's usually in the cases where there's mistakes or exceptions to the rule. But if it's just a normal business process, like I wasn't talking to people a lot. Maybe I would do things like notify them that something was done, but that was about it. It just didn't require a lot of communication. Routing slip would also be too inefficient here because I'd have to have the cashier up front intimately know like how everything should be done. And we'd have cases like, where the baseball team rolls up or the soccer team, and there's like 20 people coming in. And I'm looking at this, long receipt. I'm like, I don't know what, I as a cashier, not paid the best. I'm not here to like figure out every single step in the process. I'm just here to take your money. So the solution here is going to be something beyond just kind of the straightforward messaging patterns. Would be a conversation pattern. And the difference between a messaging pattern and a conversation pattern is a messaging pattern generally involves like at most two parties through a given protocol. If you look at something like a routing slip, it could involve multiple parties, but there's no kind of additional coordination that needs to happen. A conversation pattern is something that involves multiple messages and multiple sets of communications to be able to achieve some kind of overall business goal, whatever that might be. So looking at McDonald's, whenever I get that initial order coming in, the first thing they actually do is publish that order information out to all of the relevant services or relevant stations that are going to be fulfilling this order. So they'll say, order created. Here's the details of my order. You can go get it over here. And this is actually what I would see when I was working in fast food. Like I'd just be at my station, and then there'd be a screen above me, and then like magically, well, not magically, there was a mainframe behind the scenes or something. After the order was accepted in the cash register, an order would pop up on my screen. And the order would only pop up because it had something to do with my specific station. So each of these stations would know, like, these are the kinds of things or operations I do, so I can discard messages for orders that I don't care about. I wouldn't see that though. I would just see like, it would only show the ones that I cared about. But that was nonverbal. Like it wasn't the cashier telling me anything. In fact, they would just go on to the next person, and then behind the scenes, the message would get published out and arrive at each of the stations that were relevant to that specific order. Now, I still need to know, based on this, how an order is completed. In the routing slip example, it was easy to know the order was completed because I could look to see, am I the last step of the process? Yes. Okay, we're good to go. So like if you go to Subway, for example, like there's no question that your sandwich is done being made because it's made by one person traveling from station to station to station. There's no coordination that needs to happen. But here it's a little bit more complicated because I have steps that can be done in parallel, and I need to have some way to track to know which step is complete and which step is not. In the case of like the burger Mighty Find example, the bag holds all the items and the bag travels from step to step. So once it gets to the end, everything's completed. But in here, like there's not something physically traveling from station to station to kind of gather the things as it goes. So instead what we have is a central way of storing all of the completed items for any one order. And so you'll see this. If you go to McDonald's and you order something for in the restaurant, or even not in the restaurant, what they do is they put a tray down. And the tray basically represents your order. And initially, the tray is empty, but as steps complete, your tray will start to contain all the items that have been completed. So that physical tray will hold all of the items in your order. And then there's one other thing that's on that tray, which is a receipt that shows the details of your order. So that receipt is not the same receipt that you receive as a customer. It's something that's very specific and specialized to just tracking order completion. So it doesn't have like amounts or totals, no dollars, no like payment methods. It is just, here are the items of your order. That's it. So I have some place for things to land when they're done. How do I know if I'm an individual station, how do I know when my step is done? So let's walk this one by one. So one step completes at the dress station. They take their items, and the first thing they do is they place them on the tray. The next thing they do is they look at the receipt and check to see, are all the items on the tray in the tray? Are items on the receipt on the tray? So is this order complete? And based on this being the first step done, I can see I've only got one item on the tray, and the receipt shows 3 items or whatever. So I'm not done. So I go back and continue on to the next step of the process. The next step completes as well. So like the grill station completes, they will place the item on the tray. They will check the items on the receipt for doneness. They say, nope, that's not done yet. And so they go back and keep doing more stuff. And then finally, the fry station, the last item that they've ordered, they place the item in the tray. They check the items on the receipt for doneness. And they do see, hey, wait, everything on here is done. And so yes, ship it. Everything's good to go. So this pattern of where I have like an initial event that goes out to multiple different independent stations or processes in parallel, and each one of them completes independently of each other and then notifies some kind of central process manager that its step is done in the process. And then that central step in the process of that central location is the thing that contains like the list of things to do and what's been done or not. This pattern is known as choreography. So it's characterized by having a more event-based initiation because I can have multiple things in parallel, and the nature of events means I can publish out to multiple subscribers, and then I'm all working in parallel. No one's enforcing any kind of specific step order. So if I need to enforce a step order, that's probably something that needs to happen within a given step or within a given set of processes. But with this, I do need to actually track completion. So I don't guarantee the order in which things happen. So I can't guarantee that like, well, Fry Station told me they're done, and Fry Station is always the last station. So whenever Fry Station tells me they're done, I know that the order's done. We can't do that. Things can be completed out of order. So I need to be able to keep track of what has been done and what has not been done. I'd also call this the observer pattern before like choreography's thing, because it made more sense to me in my head. But you can kind of think of like choreography as of having multiple people dancing around together, but they're kind of independent of each other. Now there's one last step in the process here, which is I don't actually give it to I need to deliver the tray to the right customer. So I need a way to correlate those orders with people. So I need to know whose orders whose. And so when I tell people that their order is done, the person needs to know that my order is done and not someone else's order. And so I needed some way to correlate this specific order or this business process or this conversation with the overall initiator or the overall recipient of it when it's done. So there are a couple ways of doing this. One is to choose some kind of natural correlation. And so in the real world, you would see this being done with names. So like you go to a coffee shop, you tend to get a name put on your cup. So they say, okay, I want a grande iced caramel macchiato, half soy, half whip, whatever. And so they'll ask you your name so that when the order is completed, they call out your name. And as long as there's not multiple Jimmys there, then I have a reasonable expectation to get my order. However, if you have a more common name, then they might ask you your last initial or something that's a little bit more specific to you. So we'd have to really make sure that the natural correlation identifier we choose is unique to that person. So just use social security numbers, right? That was a joke. Don't do that. So for our systems, natural correlation identifiers can be a little bit trickier because it requires the initiating caller to be able to know, be able to have that information ready for them. Most typically, though, we pick an artificial correlation identifier. And usually in the real world, it's not a GUID, it would be a number. So McDonald's, like each station has a hundreds place. So it'll be like station 1 is 100, station 2 is 200, station 3 is 300. And then they just go like from 0 to 99. So it goes 300, 301, 302, all the way up. Once it gets to 99, it goes back to 300 again. We might, that's not globally unique, of course. So we might have to pick an artificial correlation identifier that is globally unique. So we'll use a GUID. But for like, restaurants, my orders don't have to be globally unique or even unique in like the last, hour. It's highly unlikely that I will go through 100 people without delivering any order, and it wraps around again in the course of like a given day. So, yeah, that's they tend to use choreography. They have a correlation identifier. They've got a central process manager, which is the tray itself, to be able to kind of know when things are done or not. And we use messaging between each individual station to be able to coordinate this overall business process. But choreography is just one way for us to coordinate a given activity. Let's also look to see how larger restaurants might work. Now, with McDonald's, what they're trying to optimize is the number of orders they can process in a given amount of time, because they know like they can also, they can crank out the food behind the scenes very quickly. They might even optimize things like, like before lunch hour rush, we would just dump a bunch of fries in the fryer because like we know we're going to need them. It takes 5 minutes to fry these things, so let's just dump a bunch in because we know we're going to need it. Sometimes we do things like drop burgers on the grill. So our restaurant would broadcast the drive-through order mic to speakers so we could actually hear what people are ordering. And so if we heard someone coming in and ordering 3 burgers, we would actually immediately drop those burgers down before they completed the order. And that was, again, to help improve our overall throughput because we want to get more orders out in a given amount of time. Larger restaurants don't work like that. And they probably felt that the most in this pandemic because larger restaurants have different profitability levers. And so for them, they're not trying to optimize the number of patrons in a given amount of time. They're actually trying to maximize the dollar amount per patron that comes in. And so that's why they'll push alcohol on you or drinks because those are a lot cheaper for them, but have a much higher margin for you. So you can order your $12 cocktail that may have only cost them like $2 or what, $1 to make. That's where they're making the margin. So the longer you sit there and order these high dollar items, the more money that they make. And so they'll have higher quality food that may take longer to entice you to stay longer, and then spend more dollars at that amount of, while you're sitting there during that mealtime. So then this means that our orders now are much more complex. Like there aren't Like McDonald's was complicated, but now we're much, much more complicated. Like we have specials of the day, different things can take a different amount of times. We could have things that take a long time versus things that take a short amount of time. So I need a lot more control over a process. So just like notifying everybody that we got an order and then letting them kind of work on their own doesn't really work for these larger, more complex restaurants. And instead we have to have kind of like a benevolent dictator in the middle. That's really the one that's like directing everything and kind of making sure everything happens exactly when it's supposed to happen by the exact people that it's supposed to happen by. And so in my head, I'm always thinking like Gordon Ramsay yelling out at people, I need this certain thing now, I need this certain thing now. And they're really the ones that are actually controlling the overall business process. So this benevolent dictator / chef, they're the ones that are really now the one in the middle that are directing each station of exactly what to do and when to do it. So they're receiving the incoming orders from the waitstaff. They're going to create their plan for completion of that order, and they're going to tell or bark orders at each step in the process at specific points times to be able to do each individual step. So the idea here is that no one step no one station is able to really reason about when it should do things. And so it's relying on a central coordinator to be able to tell each station what to do and when. But of course, it all starts out with, I need to place my order. So it's going to be another synchronous interaction, which is me telling the waitstaff, here's the items I want. So I say, I want a burger. Okay, got it. I want some fries. Need to wash it down, of course, with a pint of ale. And so they say, okay, we're all good to go. And now the waitstaff has to go to the chef to tell them that the order is ready for completion. So this is again a synchronous interaction to say, yep, I've got your order, I've written it all down, and now I'm going to take it to the chef to be able to process it from there. So they'll let the chef know with publishing a message. This message would be durable. I'm not going to yell my order out to the chef. This will be written down and handed to the chef. And you often find like in higher end restaurants, they'll have it all computerized, but some of the lo-fi ones as well, you'll see them still writing the orders down, and that's pushed onto a till, which contains the paper of all the different orders that need to be fulfilled. And then the chef or the head cook is getting those orders, reading what's on them, and then figuring out a plan for completion. So the chef says, okay, grilling takes the longest, so let me go ahead and kick that off first. So I'm going to tell the grill person, go ahead and make this burger. But the person, the customer, remember, we're trying to optimize some behaviors here. So let's go ahead and pour their pints, notify the bar to go ahead and do that, because the more they drink, the more money we make. So the bartender receives that command, pours their pints, and then replies back to the chef, pints complete, we're good to go. So now that the pint is complete, we can then go tell the waitstaff to go ahead and deliver the pint to the customer. So we'll put it on the till or put it on put it on the counter. They'll take it and they'll go ahead and deliver that pint to the customer. Well, it's been a few minutes. The burger's going, and now I need to tell the fry station to do their work, because it still takes time, but it takes less time than it takes for the grill. So we'll go ahead and tell the fry station, go ahead and make your fries. The grill station is now done, so it sends a message back. This would be a reply now back saying burger complete, back to the originator, which would be the chef. And finally, the fry station replies back as well with a complete. So instead of me, again, using events here, so I'm not publishing out, make burger, and then whoever is listening that wants to make a burger can make the burger and let me know. Instead, I'm sending a direct command to the station that needs to perform the work, and then they're replying back to me saying the work has been completed. So this is request response, but now it's asynchronous request response, where I am sending them a message to do some work, and then they're replying back to me with another message saying my work is completed. Now, me as the person that's coordinating all these activities, I know which message I've received by which person, because I know that I've sent these messages to them. And so when I receive all my complete messages, I know that the order is ready to be delivered. And so I can tell the waitstaff to go ahead and deliver the order to that customer. So this kind of coordination is known as orchestration, because One, it's started by a single message. It could be an event or command, but it's typically one single message starts a process. And then from there on out, the process manager or the orchestrator is then telling each step what to do. So I'm telling the grill to do this thing. I'm telling the fryer to do the thing. It is using commands to coordinate each step in this process. And then each step in the process uses a response or a reply back to that originator to say, I am done, and here's the result of my operation. So it's a request response or command reply, but it's a two-way conversation between the originator and the individual worker to be able to coordinate those activities. So in this case, there actually is a lot less tracking of status. I know that, like, by receiving the complete message, I know that that step has been completed, so I don't need to necessarily coordinate to know which steps, what all the steps are completed. And if I'm enforcing a specific order as well, so if I know that, like, grill needs to happen first, then fry needs to happen next, and I know that when I receive the fry reply, that means the overall process is done. That doesn't mean there's not no tracking of status, but there tends to be a lot less tracking of status because the orchestrator is now, like, coordinating and directing the traffic of exactly what to do and when. Now, there's a lot been written about, like, when you should choose what, like, when do you choose orchestration versus choreography? This is, again, one of those things. You don't want to have, like, a blanket rule that says, always use orchestration, because orchestration is, orchestration means we know exactly what should go when. Or always use choreography, because, choreography means I have less coupling between individual steps in the process. But in reality, it's never that simple. In fact, you can have processes that do both. They orchestrate some things and choreograph other things. So what I tend to do is to look at the overall process, or the overall business process, and look at, is there any coupling between each of the different steps? So do any steps depend on each other? So if there are steps that have dependencies, then that would lead me towards orchestration. If there are steps without dependencies, that'll lead me towards choreography. So what I usually see is orchestration inside of our microservice boundaries and choreography usually between service boundaries. This isn't always the case, but usually. And the reason why I say that is because typically we have events between service boundaries, because that does lead to less overall coupling. And we usually see orchestration inside of service boundaries because, this is our house. We can tell each other what to do and when to do it. Again, not always the case, but as a general rule of thumb, this is what I tend to find in the systems that I tend to build. Now, this is all well and good for performing business activities, but these are all business activities that are kind of directly exposed to the end user. So what about things that aren't directly exposed to the end user? Things like, I usually see, like, the read side of our operations. It takes a lot of background work, a lot of behind the scenes activities to be able to build out this singular view for the end customer. And a good example for this in our restaurants are catalogs and menus. So that menu is something that is very specialized for that end user, for that end customer. They built that menu and its layout and its structure to, again, inform you and to entice you and to really make sure that you actually order something. So they want to make sure, for one, that reading that menu is very cheap. So in the real world, like, it's just written down somewhere. And so the cost of me reading the menu is just, I guess, the light cost of bouncing it off on any of my eyes, but that's it. For me as a customer, it doesn't take a lot of resources for me to be able to read the menu. The menu is also special made just for the customers. And kind of critically here is that the decisions and structures and organizational patterns behind the scenes of how the menu came to be is not visible or apparent necessarily to the end customer. So they don't see, like, well, there was a marketing department, there was a food science department, there was a shipping, like, they don't see all those different people behind the scenes that went into making this menu. Instead, we have something that's kind of combined them all together and composed all this information from all these different sources to one singular experience for you, the customer. Now, creating the menu could be more complex, right? I could use, in the case of my food truck, I might have an Excel spreadsheet or Access database that tracks, suppliers and prices and lead times. And so it's really for managing the menu and figuring out like what is the best items to put on there? What should I charge for different things? It might also might contain a lot of the decisions and business rules about, I don't know, like when should we start selling the McRib again? We'll look at pork futures and see that's going to dip down. So that's a good time to sell the McRib again. It's a lot of things behind the scenes that you don't necessarily see, presented to you as the end customer, but behind the scenes, they might have those systems and applications really optimized for managing that business information and those business decisions. Might have reporting and forecasts and calculations, historical trends. It could be very complicated behind the scenes to be able to figure out, how do these different things come together to decide, here's what I should sell and here's how much I should charge for it. But a typical solution you see is like, I got one single data store, which is the same data store that I use for the front end as I would use for the back end. And for simplified models, this can work okay. Like if there's not a lot of complex business decisions behind the scenes, or we do see like the read heuristics are nowhere near as complex or need different scale than the back end. So this can work for some simplified systems and applications. But if I look at the real world, the equivalent design would be me not putting a menu out front, but me putting out the Excel spreadsheet to say, if you want to go order something, go to sheets.google.com/gobbledygook.whatever, and then that's where you'll find the order menu. But that's not what you see. You see something that's very optimized and specialized for that customer. So as a customer, if you give me a link to a spreadsheet, I'm not going to order from you. That's ridiculous. I want something that's like very simplified and just tells me the information I need to know and nothing else. So the problem is I'm trying to use the same model to solve two very different problems. But in this case, like where the reads are very, very different from the writes, then they'll have two very different sets of characteristics, and they'll probably want two different kinds of solutions. So a better solution would be build something that's very specialized and tailored for the front end, separate from the systems for the back end. And you will see this in restaurants. The menus are printed or they're put on some like board up there, but those decisions have all been kind of made ahead of time. And then the outcomes of the decisions are then printed out into something that's very easily consumed and very easy to understand for the end customer. Then the complexity here comes like, well, how do you connect these two then? How do you make sure that these things can talk to each other? So if I look at the real world, the sort of interactions I see between the customer and the menu is that typically you see the menus are updated on a more scheduled basis. So it's not like the millisecond that the business owner changes their minds about what to charge something, that price is not immediately updated on the menu. And that would be kind of disconcerting as a customer. Like if I'm looking at the menu, I blink and the price has changed. Like I hope it went down, but if it went up, I'd be upset. So instead, they want to keep the customer-facing information more stable and not be going up and down as the customer is looking at this menu. We also want to make sure that the menu itself is immutable. That is, we can't have someone else decide to cross out the price and invent a new price, which is a challenge because now I have the price like living in two places, right? The system of record of my price is the Excel spreadsheet, but as soon as I copy and paste that into a menu, I do run the risk that price could change because now it lives in two places. And so I just need to make sure like no one has crossed off the price or said, yes, I'll have a steak, but how about $10 instead of $50? Like that doesn't typically happen. It's more like these are agreed upon prices and you can't change them after the fact. Once they've been printed out, they're now unchangeable unless I get a new printout in the future. So even though the data is duplicated, right, the data lives in the spreadsheet and on the printed form, the ownership is still preserved because only the owner of that data can come behind me and change it. And you may see that sometimes, like some minis restaurants have been on, like someone has Sharpied out the price of the shrimp and put a higher price because like shrimp cost went up or whatever. But it wasn't anyone that crossed that price out. It was the owner that did that, the person that owns that data. So even though the data was duplicated, they were still able to preserve that ownership because they're the only ones that can change it. So how do I notify the menu that their changes have been that need to be updated? Well, I can notify them again via a durable message using an event to say, hey, restaurant owners, we got a new menu update coming. This menu update should come in at this specific date. So I'll probably send that message ahead of time. And here are the new items and the new prices that you needed to do to be able to put it into place on that date. So the owners of the restaurants would then go update their menus, update their placards, and then like that night, they would go ahead and swap everything out while no one's in the store to be able to get all the updated menu information. I could have multiple stores, all recipients of this new menu that I'm publishing out. In this case, the publisher is keeping track of all the subscribers. So the publisher knows I have these 3 stores I need to publish out the new menu to. It's going to be durable, so I'm not calling each restaurant owner on the phone saying, hey, Bob, in 3 weeks, I need you to change the price of tacos to $10. Got it? Got it. Okay, bye. Have a good day or something. No, I write it down. It's an email or whatever it might be. I'm going to write it down so that I, as the publisher, I'm not coupled to the other owners of the stores, like at that point in time being available to be able to answer my call and read and hear my message. We're also creating a separate message per subscriber. So when I send out this email, I'm sending out, I'm probably CCing everybody or BCCing. So that means that every single recipient gets their own individual copy of the message so that if someone is not available or reads it at a different time, it doesn't affect anybody else in this process. So I've got a durable message sent to subscribers. Each subscriber is unaware of each other unless it's CC instead of BCC, I guess. And if one store is closed or someone's not reading their email at that point in time, the other menus can still be updated in red and stores can operate, even though that one store may not have received it on time. So just some parting thoughts. The constraints of the real world haven't changed. So the same kind of communications constraints we see in the real world, those same communications constraints exist in our virtual systems. The latency has just gotten a lot shorter. But the latency still isn't 0, and so we can't assume that. So I tend to find if I can draw out my solution as if it was real humans, as each actor or service, and figure out what is the right communication and what would actually work in the real world, then I tend to find that those designs translate much better than instead of some kind of more dogmatic, thou shalt just use APIs everywhere or must use events everywhere, that sort of thing. So by applying the solutions from the real world, directly to a distributed world, we have a much higher likelihood of those solutions to succeed. And I also find that a lot of the real world has already solved a lot of these distribution problems with messaging and conversation coordination. So all these terms that we're using in the messaging world, these are things that were already figured out by humans decades, centuries, millennia ago. And it's really just up to us to recognize those patterns, recognize the constraints and benefits of when those different patterns apply, and then apply them accordingly to our individual systems. So can you? So thank you all very much. If you want more information about these topics, a couple great resources out there. I can drop some links on in the chat. Great one is the Enterprise Integration Patterns book. That detailed a lot of the initial messaging patterns I talked about. Sam Newman's book, he's got a new one actually coming out. The second edition for his microservices book comes out, I think, next month. It's also a fantastic resource as well. And I think those are the 2 really good ones that I would, yes, look at. So that was that.
It was all very excellent information there, Jimmy. I like the fact that you take something in the real world and compare it to something very abstract, which is what we do for a living. A lot of people, they look at these systems that we're building and the code that we write, and it's a very abstract thing. Like there's not a lot of physical things other than maybe a server or something. And even nowadays with, serverless and microservices and a lot of things are in your cloud, basically. You don't touch any hardware or anything anymore. So, you're taking something very real world, the restaurant in this, scenario, and using that to break down these very abstract things, code patterns. I really enjoy that. I like that. I could see a lot of things in here that apply to not only microservices, but just the front end as well. So there's a lot of patterns that we repeat just in front end presentation code. There's a lot of things that we can reuse from this information. I think it also builds a nice segue from what we were talking about earlier, which is those minimal APIs. So some of those things we can use with these patterns that you talked about. And then what we're going to be talking about next is gRPC. So we're going to be talking about gRPC in a few minutes here. Any comments about some of those other technologies like SignalR and gRPC and how they can play into some of these patterns?
Yeah, absolutely. So like gRPC is a good example of a synchronous request response. And that's still a kind of a critical communication pattern I find in my systems. Like there are definitely times that I, as a service, need to ask a question of another service and I need to have it answered immediately. I can't wait. I need it now. And so you're looking at something like gRPC is a great choice for that kind of communication style. Or even HTTP, like the front end, it's still synchronous. But using those APIs as a means of like there's still plenty of times when people need to make a request to a system and they can't wait for a response. They need a response immediately. We can layer those on with like other messaging patterns, like a claim check pattern. Is a good example of like, you ask me to do something immediately. I can't do it right now, but what I'm going to do is I'm going to give you a ticket that will tell you the status of the thing I'm working on, and then I can notify you in the future. So using something like SignalR of like notifying to say, oh, you see this in the Azure portal, right? You submit to get your database created, and then it's going to take a bit, and so it received your request synchronously, but it's not acting on your request synchronously. It's kicked off a background process to actually do your work, but in order to notify you in a more timely fashion, you get those little notification things at the top to say, yes, this has been completed, and here you go. So it's mixing like all of those things all together. The critical thing for me though is the other thing people mess up on is the user experience of all this. You can't lie to the user or trick the user about what's going on, because that's when they'll get confused. So I make sure that we're mixing async and sync, that it's still very explicit to the end user about exactly what's going on. So when you provision the database in Azure, it says like, we have received your request and here's a link to your request. And then it's very explicit about, you can go back to that request and it's like telling you the status. It's very explicit about when it's notifying you, like there's a little thing up top to say, I'm notifying you when you're done. So it's never tricking you that this is going to be a long process, but we'll be with you like every step of the way to let you know what's going on.
Very nice. We've got a question here about exception handling. I think that's another really good topic. They're asking about how do you do exception handling right with microservices and handling the bubbling up of those things.
So the first thing I do is I look all the way up to the very initiator of the process to understand what their expectation is for success and failure. So if it's a user performing some operation, then I need to understand like what their expectation for something succeeding or failing is going to be, and what are the things that I can support for success or failure. So for things like the place order button on an e-commerce website, like if that fails and I show an error to the end user, then they will lose trust in me. So I have to understand what are the ramifications of these failures, and that'll kind of tell me like how critical it is that I ensure specific steps in the process succeed or not. And if I need to have a higher degree of success, then I will choose interaction patterns and messaging patterns that carry those set of guarantees. So like when you go to Amazon.com, you click place order, they're not like at that point in time trying to fulfill your order behind the scenes. Instead, it's a very small synchronous operation where they're just recording your order, and then the only thing you get back is a thank you page that says thank you for your order. There's cases where it's more of like a read operation, like I'm trying to gather information for a page to be able to show the end user. then I have to decide like what are the things that are critical for them versus not critical. So an example would be like Amazon.com product page. There are things on that page that are more important and things on the page that are less important. Like less important would probably be the related items. Like I don't want to prevent a user from buying something if I can't find out what items are related to this item, or customers who bought this item also bought. So I might wrap that operation in either something like Poly or whatever that's like, we're going to, we'll try this a couple times, and if it fails, and we're just going to say, we don't have that, and we just won't show it to the end user. So really, for me, it all comes back to the user experience, what they expect, and from the business side as well, like what are we trying to optimize here? What I don't do though is like, just hope everything succeeds. We will go through these operations of just like, we'll draw it out and say like, this failed, what should be the experience? This failed, what should be the experience? Make sure that we've got all of those cases handled for that user.
Yeah, I think some of those things are just really difficult to think through, and they need to be, like you said, plotted out and put in front of everyone. Like you think of an Amazon order, like you gave example to, like if you put the order in, it looks successful from the beginning, but you may get emails back for, say, the transaction didn't go through on the credit card for some reason. Maybe it was close to the expiration date or something, and it passed that expiration date while you're placing your order, or maybe the item went out of stock for some reason, and you get these emails back, and you have to work through those processes to get the order back into a functioning state. Put new credit card information in, or select a different product for to replace the one you ordered,
right,
or just
exactly.
outright cancel the entire thing.
Those are often human interactions too, because they know when you get a person involved, you're much more likely to complete the order. And when I was in the card checkout team, we did exactly that. Like initially, we had all that credit card validation, even the ones like Visa needs to start with a number 4. We found that like people make mistakes, and when they make mistakes during this process, they tend to quit. And so what we wanted to optimize is people finishing that order taking process. And so we wound up turning off all validation for all of that stuff. Like we didn't do the loon check to check the check digits on the credit card number. We didn't check expiration dates. We didn't validate addresses. None of that stuff, because none of it was critical, because we knew we had an actual human order processor that if something kicked out of the automated process, they were going to get on the phone with you to be able to complete the order. And then that makes our order acceptance rate go from 90% to like 99%, because we got that human in the process that's been trained to like be super nice and not say like, you idiot, you transposed your numbers again on your credit card.
Yeah. We've got a question here. I don't know if this is supposed to be Dapper or if it's just DAPR. Are you familiar with this? Oh, yes. Okay. I thought it had 2 P's in it. My mistake, I guess.
Well, there's another Dapper, which is DAPPER, which is the micro ORM from the Stack Overflow folks.
Okay. We were talking about that prior to this talk. So, and anyhow.
No, Dapper is it's kind of a microservice. I should just go to the website and tell you what it is, because I'll get it wrong. But it's a way for us to make it easier for us to build, define, develop, and deploy microservice-based architectures. So it lets us, if I need to have like these 3 services up for my application to run, then Dapper makes it easier to do that, and it works and it integrates with things like Kubernetes easily and other container orchestrators. Although you have to have container orchestration to be able to do so, but it lets you kind of more easily develop and define microservice-based architectures in the kind of more modern style, containerized style. I haven't used it though. It's just like interesting to look at. I'm just kind of keeping my eye on it in case I get the opportunity to actually use it.
Yeah, I'll share one with folks too while I've got you here. I don't know if you've been tracking this one, Jimmy. Have you looked at Thai at all? So this is kind of a collection of microservice frameworks and patterns and things that the .NET folks are working on. So this is a good project to kind of keep your eyes out for. And I believe this stuff gets funneled into like the .NET templating and Visual Studio experiences and stuff. So this is a nice place to keep tabs on all the microservice stuff that's going on over in the .NET land.
Yeah, it's a whole world out there. You've got, do you do a mono repo? Do you do repo per business domain or repo per microservice? Are those different? Like it does become more complex when you're looking at the kind of DevOps side of things of how do you manage all this stuff. But I just kind of hand wave that and say automate the things, I guess.
So I just want to tell you, thank you again for joining us here on Code It Live. Fantastic presentation.
Yeah, thanks for having me.
Really good stuff. I love relating, again, the real world kind of stuff to what we do. It makes kind of, understanding the problems much easier. And I think people really enjoy seeing that stuff. So any links or final words, Jimmy?
No, I do have some links, but I'll drop those in the old comment thing over there.
All right. Well, thank you very much, and enjoy the rest of your afternoon, Jimmy.
All right.
Take care, my friend.
All right. Bye-bye.
So I've got another guest lined up here. I'm waiting for my good friend Sam Basu to join me in just a moment. We also have prize giveaways today. So we are doing some drawings for prizes, and you may have seen some of our messages going out to get in that drawing, and I'll cue that up once again so you can be part of that drawing. There we go. So if you jump on that link, we're giving away 3 $50 Amazon gift cards today. Just jump on there. Basically, you got a couple fields there to fill out, and we will get in touch with you at the end of the show today. We'll announce those winners. We'll send out emails to those folks. We've had some great guests today so far. We've had Khalid from JetBrains. He was talking about minimal APIs. There's lots of nice features coming with .NET 6 to minimize the amount of code that we have to write in our ASP.NET web apps to do web APIs. So really great stuff there. And then we just had Jimmy on talking about how to build proper microservice architecture and comparing that to some real world scenarios using restaurants. And one thing I'd really love to see, I know this is really probably breaking off a big project here. I'd love to see a workshop based on all of those restaurant patterns and things. That'd be really cool to see. So that's something that would be fun to take and run with and try out some of these different architectural patterns. And then in just a few moments here, we're going to talk about gRPC and what that is doing in the next version of .NET, where we are at now, what's coming up soon, and how you can get gRPC integrated in your applications. So just stick around for one quick moment. I'm going to ping some of my friends backstage here. We should have Sam coming up here in just a moment, and then we will kick things off once again. So don't go anywhere. Stick around, and we will be right back. All right. Thanks for the quick break there. I just had to check and see where folks are at. And we've got our guest waiting backstage. And I'm waiting for my co-host here. He's going to take over here in just a moment. There we go. He's joining me now. And if you have any questions, feel free to hit us up here in chat as well while we transition over to the next segment. Sam, how are you doing, my friend? Are you ready? think Sam's working on his audio. We'll give him just one more second. He's having technical difficulties, folks. So we will give him just a minute here. There we
good,
go.
I think
Sam's good now. I can hear you. I can hear you, Sam.
Just my AirPods didn't connect right away.
So we've had quite the productive day here on Code It Live, Sam. I was telling the chat room, and if you didn't catch these, folks, by the way, you can hit the recordings on our YouTube page shortly. We'll get those posted up on our GitHub, our YouTube at, let's see, I think I'm hitting the right bot tag there. We will have it on our YouTube channel. You can follow that link there to get the sessions that you missed. But we had Khalid from JetBrains and Jimmy Bogard. So Khalid filled us in on all the minimal API stuff that's coming in .NET 6 and beyond. And Jimmy laid down the foundation for building out microservices, something we could apply those minimal APIs to. And then I said that was a nice bridge to bring us over to gRPC. And Sam, you have a guest here with us that we'll bring on to talk about gRPC.
Absolutely. Yeah, sorry to be a couple of minutes late. You go pick up your kid from school, and there's always something or the other happening at school or summer camp, right?
Always.
Somebody fell, somebody had stuff. But I am back, and looks like our next guest is on. Shall we bring him on?
Absolutely.
All right, so if it's ready. Hello, can you hear us?
Good morning, folks, or I guess, is it morning for you?
Good afternoon. Ed and me are both on East Coast. Wait,
I see.
I froze.
Yeah, Sam's video froze here. We'll give him a second to unfreeze. But looks like he's going to drop for a second. Welcome to the show. It's nice to have you. So I know I'm going to get the last name wrong here. So if you don't mind, how do you pronounce your last name, my friend?
Shirhatti.
All right. So Sourabh Shirhatti is here from Microsoft to talk to us about gRPC. Sam, are you doing well there? You got your connection back, my friend?
I think so. It wasn't my connection. Like sometimes my camera is like, I'm tired of you. I don't want to see you anymore. So technical blips, but I think I'm back. I'm good. So Ed will let you hop off, and I know you have like a late lunch, so go do your thing.
Absolutely.
Yeah. All right.
Take care, gentlemen.
All right. Thank you. All right, Sourabh, how are you, sir?
I am doing good. How about yourself, Sam?
I'm not too bad. I have known you for a long, long time. I don't think we have spoken a lot in person, but I've definitely seen you around like MVP Summit or other times we're in Seattle. And where are you? Are you in Seattle?
I am. I'm in Bellevue, but the greater
Bellevue.
Seattle area, yeah.
Yeah, perfect. All right, so good morning to you. And folks, good afternoon, good evening if you're just joining us or if you have been hanging out with us. It's been a fun day, so I'm going to do the what again. So what we're doing here is Back to the Future. So we are kind of standing on top of ASP.NET Core, which I don't think we talk enough about. We are always looking ahead at Blazor and .NET 6 and Maui, but you can be very productive with all the stuff that's baked in, and that's been all the innovations that's been poured into ASP.NET right now. So maybe introduce yourself to us one more time. You work on the ASP.NET team?
All right, so I've been at Microsoft and on the ASP.NET team for about 6 odd years right now.
Nice.
So I work closely with our server stack. So, poke my fingers here and there with guest role every now and then, and just generally work on our application frameworks. I tend to work close to lower in the stack, so I'm not quite on the Blazor train yet, but definitely gRPC is something that I've been part of for a while, and definitely passionate about.
Nice. I will be your annoying sidekick that has lots of dumb questions along the way. I'm here to learn what is gRPC, what was the inspiration to get it baked in and working so nicely with ASP.NET, and where are things now, where are things headed tomorrow. So go ahead and share your screen whenever you are ready.
Right. So,
and we'll bring it up.
so yeah, I can share my screen. I don't quite have anything up just yet. Let's see. So I just
Yeah.
sort of have
Yep.
my,
Yeah, see it?
I guess you can see it. I just have some notes for myself, like as we talk through it. But
Yeah, yeah.
I kind of want to, what you alluded to, like you said, Back to the Future, building on what we have in ASP.NET Core. I think it's good for a timely reminder that we don't just start building new app models, app frameworks, and abandon them, right? A lot of the innovation that you see, like even the new minimal host builder, right? That works with all our app frameworks and app models. So you can see that gRPC integrates into that world. And so I'll probably just take a step back. Let's talk about the genesis of gRPC. Right? Like for as long as computers have existed, people have wanted to make remote procedure calls. Right? You need to make you need to call a method or stub on another machine and make it appear like it was local. We've had different solutions in the past. WCF is the one that I think most folks here will probably remember. But when we're looking at .NET Core and building a performant uh, RPC stack, we're like, let's look at what folks have done elsewhere, right? And I like to joke that we've previously suffered from the not invented here syndrome, right? Or at least I know people will be critical of Microsoft for that. And I want to say with gRPC, we've embraced the proudly found elsewhere. Right? So I mean, there are
Yeah.
reasons why people would pick one RPC stack versus the other. But I think something that is hard to argue with is if it's widely adopted and there are implementations in multiple languages, that sort of makes it most compelling. Right? People
Right. Yeah.
polyglot environments today. You have one team working in Go, another team working in Java, another team working in .NET. It'd be great to have an RPC stack that all languages can communicate.
So maybe take us sort of maybe one step back. So again, folks in the chat room, if you're just kind of new to ASP.NET and RPC, so these are remote procedure calls, right? And like you said, gRPC as we know it today, it's an open source framework. But did it have like the beginnings were at Google, right?
Right. So it comes from or is I guess based on a project called Stubby that first was born at Google, and everything that I'll be showing today, and for the most part, when you hear people speak about gRPC, they're really talking about gRPC with protobuf as the serialization format. But really, this isn't like the RPC tech is agnostic of the serialization format that you do use. Uh, and
And protobuf itself, like protocol buffers, like that's also open source, right?
That is correct, yes.
Yeah. And then we use like protobuf, like I have done like SignalR back in my days, and SignalR today uses protobuf if you wanted to. It can use JSON, or it can go back to using other like
message back,
like,
right?
Yeah, message back. Okay, so and how long has gRPC been around?
Ooh. I think you got me with a bit of trivia there. I can say
Yeah.
our .NET implementation probably goes back about 3 years.
Okay.
So
Yeah.
a little more context. So the gRPC team maintained a C core server, right? So it was a gRPC implementation written in C, and then they had language specific bindings. So there is an implementation. Like if you go to NuGet and search for gRPC.core, that is like the .NET bindings over the native C core implementation that exists in gRPC. When we came and took a look at it, we're like, hey, we've done all this work in ASP.NET, like some of the stuff, right? Like maybe 2 years ago we were talking about endpoint routing and how it can integrate with other app models. We're like, this would be a great candidate for something that we can integrate right into ASP.NET. And we know from feedback that people, like our opinionated model, we have like DI built in, but once you opt into our like container, you sort of get all the goodies out of ASP.NET, right? You get logging, you get our configuration system, options binding, stuff like that. So there's no reason why people wouldn't want to use that. So it was a natural candidate for us to build something. And all the perf work we've done in Kestrel too, like now gRPC users will benefit from that. And we've sort of, we started working with the upstream community, and like the implementation that I'm showing you actually lives as part of the CNCF project. So it's not like a Microsoft owned thing. It's actually part of CNCF, which is like Linux Foundation project, and it's had a like it's been reasonably successful. It's had a good uptake, and the upstream gRPC project now is choosing not to maintain both implementations. So I think we're at the point where the older C core based implementation is now being sunset. I forget the exact words on whether it's going out of support or it's maintenance mode only, but I guess the simpler thing to tell is if you're looking at gRPC and you're a .NET developer, the implementation I'm showing you is the one you probably should be looking at.
Yeah, makes sense. And folks in the chat room, that's the CNCF that Sourabh mentioned. That's the Cloud Native Computing Foundation, right? So
Right.
a lot of open source frameworks live there.
So maybe it makes sense to start right from the basics, like what does the hello world of gRPC look like? And
Yep.
then I had my cheat sheet up. I have a couple of other features which probably make more sense once we've seen a hello world example, and it's sort of indicative of how this isn't just a toy thing. It has all the features like and the robustness and richness needed to build like applications. So what I've done is, I should have this open. So all I've done is created a new project. Just in the interest of time, I already went through the file new project, created gRPC project.
Sourabh, just one quick thing before you get started. Can you bump up your fonts?
Oh, sure, absolutely.
Yeah, thank you. Yeah, just that will do.
Let me maybe scale it down a little bit. Okay, is that good?
Yep.
Yeah. So one of the things that you'll see right off the bat, remember I was telling you we're building upon stuff in ASP.NET. If the stuff that we've been talking about, the new minimal builder, top level statements, it should come as no surprise that when you look at the gRPC template, it actually looks very similar to that, right? It is using top level statements. It is using the new builder. So it's the new builder isn't like a fork or a world of its own. It works with everything that we have already.
All right. So I had a quick question, and our chat room is funny here. I get trolled all the time, Sourabh, for not using dark mode. And
it's funny, actually. The reason I don't use dark mode is I end up sharing my screen so often. Like dark mode isn't really great, especially like back when we were in the office with projectors. It really didn't work. So.
Yeah, exactly, and that's what like Foolish Nebel is taking. Like for presentations, light mode is just so much easier to read. But again, like dark mode has like accessibility benefits, particularly good on your eyes if you're working late at night.
Right.
So one quick question here: when you say like we are using the builder and the newer minimal systems, this project, like, is this like .NET new with the CLI tool, or is this like what are you running this on?
Oh. It is, so the templates that are part of Visual Studio are the same templates that we ship as part of the CLI. So, I can maybe just, better to show it explicitly.
Yeah, we have time, so yeah.
Yeah, always the things you do to save like 2 minutes end up not being worth it.
So you're in regular Visual Studio, or is this VS 2022?
This is VS 2022.
Okay.
But the gRPC templates have shipped in Visual Studio 2019 as well. It's just,
okay.
Sort of the tax you pay. I'm on Windows 11, Visual Studio 2022, .NET 6 nightly preview.
Yeah, I bet like internal nightly bills and all that fun stuff. Okay, so that's the gRPC template.
Right. So all I did was that, and I went ahead and created that project. I'm going to just, yeah, sure. I'll go ahead and hit next. The only thing I sort of cheated and made it easier for myself is I like put a few stuff in comments, which is why I was. But that's okay. We can do that. Sorry, it just pops up on another monitor. And yeah, so just use the gRPC template, and you can see this is what I end up with, right?
Yep. Okay.
Not too different from what I showed you. So let me just go back to the editor window I already had open. So like we said, gRPC is an RPC system. One thing to note is it's contract first, right? So like I said, I'm going to be using protobuf because that's sort of the de facto way to do gRPC, but gRPC itself is agnostic of the serialization format, and you could potentially use something else. So what I've done is, you see, I have a directory called protos here, and in here I have so this is my like interface definition language, right? So you'll see two things of interest here. One is you'll actually see my RPC definition, right? And then you'll also see like the types I use, right? So the say hello RPC has a hello request and hello reply. And so I've also defined the types here, right? So now there's a little bit of, I won't say magic, a little bit of wire up. So I'm just going to jump to the project file so you can see what's going on. So I've included the gRPC.ASP.NET Core package. So this is a meta package, so as to speak. So it does contain, like the tooling required to generate like C# stubs from the proto files that you've written, right? And it also contains the actual runtime bits. And now that I've done that, I've also gone ahead and included this IDL file that I wrote as part of the protobuf item group, right? And then in this like gRPC service attribute, so I have to specify whether I'm generating stubs for like service stubs, or am I generating client proxies if I'm a client trying to make calls? If you're working in Visual Studio, though, you don't have to directly deal with this. We have this like pretty nice experience where if you go to a project, you can say add service reference, right? And you have this whole experience where you can just like rely on the Visual Studio tooling, where you go ahead, you can point to a file or a URL, and then you can generate just the service stubs, the client proxies, both, or just the messages if you're just using protobuf for serialization, right? I'll go through this wizard in a second when we jump over to the client side, right? Because it's similar, right? Like you're using the same contract on both the server and the client. So
Okay, so Sourabh, before you proceed, two quick questions. One is from the source room, Full Schnabel, and I will highlight things just so I can ask you. So is it using source generators, like C# source generators, to kind of look through the protobuf thing?
It is not using C# source generators.
But it's using something to kind of give you that client and server.
Correct, yeah. So there is some shared infrastructure in the protobuf community that we could use. So there is Protoc, like the proto compiler, and the proto compiler has the notion of I forget if they're called extensions, modules. I'm probably going to butcher it, but the idea is for us to have used source generators, maybe something we can consider in the future, we would have to have knowledge of semantic knowledge of the protobuf files, right? Today, we are not responsible for parsing the files. We can use the existing infrastructure, like we use the proto compiler, so we don't have to maintain that. So it's a trade-off, something we can look at in the future.
Yeah, makes sense. And one more follow-up question: Can I use this in F#?
So what you'll have to do is we only have the proxy generation and stub generation in C#. So you would have to create a class library, add reference that, and then you can have a CLS compliant type that you can then consume from an F# project.
Interesting. Our chat room can be a little brutal at times. Like we love our F# and VB at times, but we also realize like the reality often is with C#. And then my question was like going back to your protobuf definition, like the proto 3, like that's just a version of protobuf. Is that what it is? Like the syntax? Okay. And just kind of going back to, you mentioned like WCF, which for a lot of like us people who are a little old and kind of have seen that, this whole model of doing the contract first, like, do you have any reservations against it?
It is so sort of like if you want compatibility, right? If you want to be compliant with all the other implementations, there's sort of like, table stakes or the rules you have to play with. If you were to write, let's say you were to do code first, right? Then there would be additional constraints or semantic conventions that you would have to follow. Like today you can use gRPC in Swift, you can use gRPC in C#, right? So some of the things that you'll see is you don't see me using any like generics in my RPC contract, right? That there you can make the case that it may have been, it may improve developer productivity or would have enabled some scenarios, but it's sort of you need something that would work in all languages. And I think one of the ways of enforcing that is to be contract first. Now, that said, there is a project called, I think it's called ProtobuffNet by Mark Gravel, where he has both a protobuf implementation, which allows you to define your contracts and code first. And then he also has a gRPC implementation that builds upon, like uses primitives from this gRPC implementation that I'm telling you about, that allows you to do code first gRPC. I know Mark does a fantastic job. Like last time I peeked in his repo, I know he had like he was testing his implementation against like the proto compiler, and he had like cross compatibility tests. So there are options. I just would say at this point it's not idiomatic gRPC.
Gotcha. Okay, so Sourabh, I don't want to hold you up. So do you want to have us like see this thing working, or if you don't mind slowing down, then the chat room actually does have more
I think
questions
that
for you.
the chat room is good. Right? Let's keep folks engaged. Let's give them what they want.
This is interesting conversation for us to have, right? So where is the generated code? And Quad Ventisar is asking, can I import a remote.proto file?
Right. So, let me just actually that's a good segue into what I plan to demo next anyways, right?
Okay.
And then you can see it. So all I did is in my solution, I went ahead and added a new project. This is just a standard console app, right? Nothing interesting, just top level statement, right? So now I'm going to go ahead in this project. I'm going to click add service reference, choose gRPC. Now I'm going to point to a proto file. So I think Quad Ventisar was asking, can I point it to a URL? You can.
Yeah.
We actually store a copy of that file locally, because this isn't something like a dynamic proxy at runtime, right? It is something that at build time we generate service stubs. So you may want to point to URL, you may want to like check it in or something. So I'm going to just navigate to my other project. So in my server project, remember there was this protos directory, and I'll add a link to this file. And then, this is a client project. So I'm going to go ahead and say, generate the client code for me, right? And you can see it does a bunch of things like including add package reference. Because I only had a console app to begin with, right? This console app doesn't even know what gRPC is. So it's added all the right package references. And so if I go back and now look at my project file, sorry, that took a long time to remember. You can see I have a reference to google.protobuf, the gRPC net client factory, and then the tools package. And then you can also see, like, similar to what we saw on the server side, there is the protobuf item group, and I have a link to that proto file.
Yeah, gotcha. And follow-up thing, maybe Quad Ventisci, like, does the URL support authentication? Like, this is the like definition that we are bringing in. It's a file that we are bringing in. So,
Right.
are you asking like if like the service definition is behind an authentication, maybe? Because like you're literally pointing to a file.
I mean,
at this
yeah,
point.
we haven't over-engineered this, right? Because this is like obviously a design time thing. If it's auth, do you want your like developer tool to directly go fetch it? Maybe get a copy, check it into your repo. Uh,
Yeah.
it's also just to me, if you're making like if you have the permissions to access that service, because you are doing an RPC call, it does feel weird that the service like the IDL is actually behind auth. So
Yeah.
I don't quite know the user scenario, but the short answer is no support for URL authentication. If you craft a compelling story, then I might be tempted to say let's do it.
Yeah. Okay, so you brought in the protobuf, and then you get all of
Yeah.
these references.
Right. So I saw a couple more questions. Maybe we should just
Yeah, so
you know
this one is a loaded one, and I was going to ask you like some more broader questions, but again, going back to WCF, right, and what we did, we had contracts, and we have generated stubs, and then the clients would pick up. Um, I don't know if we need like a magic wand, but maybe the question is to back up and say at like what are some of the use cases and scenarios where if you had used WCF in the past that you need to look at gRPC today?
uh I think it's that it's hard to like cover the entire gamut, right? People
You know?
need to make calls from one machine to another, and there are a couple of options you have today, right? One, use an HTTP API, right? The other option is use SignalR, and then
Mhm.
gRPC is just another option that we have. So based on your scenario, what your goals are, any one of those may be a good candidate, right? And there are some things that we probably don't have the equivalent for. Like if you were doing like reliable session, like WS reliable session, I don't know that there is like a an exact translation. We've almost come to the point where the patterns that you use are slightly different, right? Like if I'm writing a HTTP API, I might be using something like a pattern like CQRS,
Mhm.
where I'm going through a reliable uh, like event hub or a message bus, rather than relying on the entire transaction to be present. So you may also have to use a slightly different paradigm. So there is no like automatic conversion. Now that said,
Yeah.
I will give a small shout out to our friend Mark Randall. He uh, or through his company, I forget the exact details, but there is a product called Visual Record
Mm.
that
And
has that has a bunch of smarts in terms of converting WCF to gRPC. I cannot speak for it myself. I have not evaluated myself, but I've heard it at least it works reasonably well for simple projects.
yeah, I've known Mark, very very smart
Yeah.
man. Yeah, and in the chat room, like John Muller looks like
Yeah.
you're using core WCF, and then would
So
rather
so
move to HTTP API or gRPC.
so core WCF is a great project, and I speak with Matt Connu on a regular basis. You will not find a person who's more passionate about WCF than Matt. So for folks using that, like, know that you're in good hands. For folks who are not aware, core WCF is a community project and the genesis of that project is Microsoft donated code that was part of WCF to an open foundation project. Now it's a part of the .NET Foundation, and the goal is to create a server uh, a server-side implementation that is like binary and wire compatible with WCF. Right?
Hmm.
So it's meant to solve like certain problems. Like let's say you have a client application, right? Some WPF app that you've already deployed that uses WCF. and now you want to change or modernize your backend and move to like .NET 6, then Core WCF may be a good candidate for you, right? It's really the promise of preserving the wire compat that makes it compelling. Again, it doesn't support all the WS star protocols, right? So take a look and follow the project closely. I think Matt and the folks at Core WCF are receptive to feedback too. So file an issue and help him figure out the right thing to do next. And remember, I just want to, just for the sake of completeness, I spoke about the client side, the server side of it. As for the client, if you want to modernize and you want to talk to WCF backend, but you're only modernizing the client, .NET Core and .NET 6 has support for WCF client. So that has been there for a while.
Yeah. Interesting. I didn't know this. And like in chat room, Anup CM is thanking John Muller. So John Muller, thanks for bringing that up. And while you were generating that, or you going through the wizard, I think Food Schnabel was asking, like, where is the generated code, like the stuffing?
So I'm going to go hit this button in Visual Studio Show All Files. You might not have seen this before, and now you can see that
there it is.
in my obj folder, if I expand it, debug net6. So you see these files? There's the greet and the greet gRPC. Wait, I know it's a little hard to see. Let me see if this works. There you go. So yeah, this is the file that has the exchange types. So your hello request, hello response hello reply will be in here, and this has the client proxy. So this is the client you can use to make the call.
Nice.
I actually don't know if it zoomed in or not because
no, it did actually.
Oh, it did.
Yeah.
Okay, because it skews my own screen.
Yeah.
So
no, zooming is sometimes like hit and miss while streaming. Interesting. And then what happens if you look at it? Like if you open it up?
Let's take a look. It's all hidden inside this designer generated code. So
it's fairly readable. Yeah.
Yeah, I'll say it's not necessarily that interesting, but by all means, like feel free to dive in, take a look at this. Like, I mean, if you are using gRPC, this is compiling into some and shipping as part of your apps assembly. So by all means, like audit this code. Feel free to. Right.
Yeah. Yeah. And are there? So John Muller is talking about IIS hosting. Like, are there any issues that you know of?
Yeah. So gRPC uses HTTP2, right? And that's sort of a key thing. There were some limitations in there were limitations in IIS in terms of how full fidelity its HTTP support was, and I'm very well versed with this because my the other half of my job is trying to fix stuff that goes wrong in IIS. And it has
John
proven...
is saying, sorry to put you in a spot.
No, I think context is important, right? I think it's there are some benefits like with Kestrel, right? Kestrel is an application server. I want to add support for a new protocol. Great, I just ship a new assembly, right? IIS builds upon HTTP sys, right? Like HTTP API.dll, which is actually like a kernel mode HTTP driver. So you have to recognize, for us to get changes in there, we're talking about changes to the Windows kernel, right? And we are working our way through it. So on the, latest. So on Windows, the latest Windows client, you will find that both HTTP sys and IIS have support for it. I see John's asking Windows 11. I want to say even before Windows 11, I forget the exact build. I can pull up the details, but Windows 11 certainly. And I want to say Windows Server 2022, but I will be honest, I forget how the Windows, I forget which client is based on which server version. It isn't that straightforward anymore. But yeah, on newer versions, it definitely does work, right? I'm taking a look to see if we can get it working on older versions, but the risk is always I'm asking, can I modify the Windows kernel? And I will always be met with like angry glances, and it's difficult, right? We have to make
Yeah.
sure it's stable enough.
Yeah, absolutely. And Sean Bloch, if I'm saying that right, was asking, will this be available to standalone console apps? By this, I'm guessing like the whole interaction and how you're consuming Protobuf. I mean,
I think I get what Sean means. So like definitely on the client side, let me just show you. Well, I guess I haven't written the client code in, so let me put the client code in. I had it somewhere here. But I think I understand his concern is more on the server side. He's like, hey, I just probably have a simple app, right? I don't want ASP.NET. I don't want DI. I don't want all of that stuff, right? And I challenge you with, well, an ASP.NET app is really a console app, right? I need to understand your reasons why you probably can't use ASP.NET. There is no way to use it without our hosting model, right?
Yeah.
Let me, oops. But this has a little more than just a hello world, because I also added a deadline in there, but I can clean it up. But like at least on the client side, I think, Sean, you get the idea, right? It's you create a channel with an address. So you're saying, hey, my server is at this, is listening on this, and then this is my strongly typed client proxy, right? So this is coming from the generated code, jump into this is the generated code. And then once I create a client, give it a channel, and then once I have that, I just on the client I can call into my RPCs directly, and you see this say hello. This actually maps to the name of my RPC.
do you get
Right?
IntelliSense?
Yeah, I do. So let's do this. Let's do a fun thing. Hopefully nothing breaks. Let's create a new RPC called say hello to, right? And in fact, because of design time build, I shouldn't even need to do a full rebuild. I should have like IntelliSense here where I can say client dot. Looks like I might have to force a build. Oh, sorry. I always forget that when you share your screen, your computer becomes like unreasonably slow.
Tell me about it. Yeah.
And there you go. You see, I have
Yeah.
say hello, like so.
Mm-hmm.
And then let me zoom in case it's not visible. So
Yep. No, you see it.
yeah. But yeah.
And this is the client side code that you're showing us, right? Okay.
And then we can take a look at the server too. So let me show you the server. So actually, we didn't actually get into how it works in the server, right? I just showed you the interface definition file. So I just showed you the greet file. I never actually showed you the implementation of the service. So let's start in our program. Let's look at what we're doing, right? So we need to add like the right services. So you add gRPC. And then you need to, so this is like endpoint routing, right? You need to map this gRPC service in. So like it actually gets routed to. And then what is this gRPC service? Let's actually jump to the implementation of that, right? So the reason an implementation exists is like this was the hello world example that was part of the template. But if you were starting out, right, like if you were writing your own RPC, you'd probably be doing something like this, right? Like I was able to like create an override because this was already part of the generated base class, and now I just get to implement my own RPC call, right?
Mm-hmm.
So that's sort of how it works. And then I guess moment of truth, I should probably run this at some point, right? So let
and
me.
then I have a few more questions for you, but go ahead and run.
Sure.
Let's see.
Oh, shoot. I have some. I may have some issues with my Visual Studio build, so I'm going to drop to the command line and try running this. So, we can pull up questions while I do that, I
Yeah.
guess.
Oh, and again, don't even apologize for MS Build and Visual Studio. There are like so many moving pieces now. Like I live a lot on the .NET Maui side, and there's just like so many things changing. It is like a miracle when I have like days where my build system is fully working. So again, coming from a client developer's mindset, John Miller was talking about gRPC web. And now, I mean, when you talk about gRPC the way you are, like this is for the web, right? Or when you say gRPC web is great for Blazor, by the way. So what is John meaning here?
I see. Okay, so like I said, gRPC uses like the full fidelity of the HTTP2 protocol, right? There are some things that a lot of HTTP clients don't expose. One example of that is your browser-based clients like XHR2 or Fetch don't give you access to the full framing of HTTP2, which means you cannot communicate from inside a browser-based client to a service backend using gRPC. So as sort of part of the gRPC family, there's another protocol. It's called gRPC Web, right? Which doesn't rely on all the features of HTTP2, but that also means there are some limitations. Like you cannot do full duplex streaming, right? Because you don't have access to that. So what John's saying is, if you need to talk from either Blazor or even another like SPA-based front end, or really any client-side browser-based client to a backend, gRPC Web is a good candidate because you still get all the benefits of like you can describe your RPC in a interface definition language. You can use tooling to generate client proxies or service stubs, right? So if you're using Blazor, like you get like a .NET based client proxy. If you're using JavaScript, you can use the gRPC toolchain to get your client proxy there as well. So it does give you some like developer benefits, even if you're not like getting some like the full things like full duplex streaming.
And is that gRPC web, like, is that just a NuGet package that I can bring in?
It is, yeah. So for the server, I forget now if it's part of the meta package or not, but you can always add gRPC web server. Let me just simplest thing is the doc should probably make it clear. All right, well, I actually didn't intend to open. Right, so there you go. You just have to use gRPC web. Oh, let me zoom in. Right, and then on your endpoint, you need to annotate it with enable gRPC web.
Got it. Yeah. Okay.
And I guess John said additional package. Oh yeah, right. So it says so right here. So you do need to pull in an additional package. I'd forgotten if it was part of the meta package. Yeah. So you can use it from client apps to talk to your service backend. You can also use it from a non like a browser-based client, just like like John was talking about the limitation where most deployed instances of IIS don't support this. You can use gRPC web for now, and then as long as you're doing like Unity or service streaming calls, you're fine. And when you need something like client or duplex streaming, and hopefully your server is updated by that point in the future, you can use full gRPC.
Interesting. Okay, I'm learning a whole bunch of new things that I never knew. What is gRPC BD?
Bidirectional streaming.
Bidirectional.
Yeah.
So, like, I think like others in the chat room had this similar question. Like, when you talk about like streaming, are we talking about like the kind of streaming that SignalR did? So like, is it like server down to the client, or is it like full duplex?
So there are three types of streaming. There is server to client streaming. So so the client will send like a payload of fixed size, and then the server will, stream responses. There is the other option where it's client to server streaming. So the client can keep streaming to the server, but the server will send a fixed response. And then there is both the server and the client can simultaneously, stream to each other. And like in all these cases, remember, there was no like temporal relationship that I established. It isn't that the client has to finish sending and then the server sends or anything like that. When we say it's fully duplex, that means really both streams can operate independently.
Got it. And another question here. Sorry, we're just like peppering you with questions.
I think the one thing I owe people is sort of doing the .NET run on the client.
Yeah. Go ahead and do that. Let's do that first.
And I mean, it's sort of not the the most exciting demo in the world, but we just made like an RPC call from this.
Okay. So you had a greeting "Hello World" come back,
yeah,
and that is.
And then you can see over here.
Yeah.
It was actually it's built on top of HTTP, right? So you might be able to see. How do I? Sorry, I am not great with this Zoom tool, so I apologize. Okay, there you go.
No,
so it was an HTTP2 post, and it was made to this endpoint.
Mm-hmm.
Right.
Okay. Right. So now this might be a valid next question to ask. If you're doing stuff over like protobuf, how do you inspect the traffic, like the payload?
I'm actually not aware of any tooling that. I'm sure some stuff exists. Nothing that I know off the top of my head.
John Muller said F12.
Well, I think to foolish snabbles, if I'm saying that to their point, even if you open it in the browser tools, right, it's a binary payload. So how do you interpret that?
Exactly. And then Quad Ventus, I mentioned something that we make, and Fiddler will. I mean, it is a network proxy, so it'll show you everything, but like to Saurav's point, like, and even in DevTools, like at some point you're going to hit that binary package, and beyond that, like, how do you make sense of that?
Yeah.
It's just like serialized. Okay, now when you talked about a few of these things, like with gRPC Web, the one question I had is like some of the scenarios in which gRPC can really shine. Like you are talking about a server stubbing, you're talking about a client stubbing. So is it fair to say that if you have like a team where you're building an app where you have multiple app layers, right? And you're talking across teams, or maybe you're exposing your services out as an API, this is where gRPC can shine, because it gives you that contract to kind of fall back on, so everybody is doing the right thing, or kind of doing the handshake before.
Yeah, I mean, that's sort of the premise of most RPCs, right? Like the consumer in one process doesn't.
Okay, let me see. Maybe Saurav's video froze or network froze. We'll give him a few minutes to come back, maybe. Let's see. Break up. No, we're not breaking up. But yeah, tech issues, internet issues happen. Let's see. What were you saying? Full Schnabel. Avro has the idea that it always provides the schema so you can deconstruct it, but OFC, that takes space. Okay, I do not follow what you're saying here, because maybe I'm not following the acronyms. What is OFC? I see the follow-up questions, tough questions. No, he'll be back. So he just dropped out, and now my face is way too big than what I would like it to be. OFCs, of course. See, I'm not cool enough. So my kid is 5, so I'm just kind of catching up on like toddler pop culture yet. I'm not quite caught up on some of the short form of a lot of different words that are used on social media these days. I'm old. Let's see. And what did you mean by Avro full schnabel. I don't know what Avro means. Okay, Sourabh is back, and I kind of see his camera is coming in through like an OBC camera. We'll give him a second. Oh, Avro is a protobuf kind. Interesting. Sourabh, can you hear us?
I
We
can
see
hear
you.
you, but I have disappeared into my own green screen. I just had a blue screen.
Oh, this is brilliant.
So,
Well, we're talking to a bookshelf. That's very intelligent. How about
so give me a second. I would, since I've gotten so used to the green screen, I would turn it off and just let you see me, but I fear for what is behind me.
that? Fulsham was saying that the AI broke down. It just got too smart that it just decided not to show you. Like your background was good enough.
So no, my machine just restarted, so everything has to come up.
Oh boy, yeah.
So
I've
what
heard that.
what I actually do for my camera is there you go, I'm back.
Stop moving.
No, I use. So when the whole pandemic started and there was like a camera shortage, you couldn't get a good web camera. I stumbled across someone's suggestion to use your old Xbox Kinect as a camera.
Oh yeah.
And the Xbox Kinect actually has an IR camera as well, right?
Yeah.
So it gives you a really good green screen without actually requiring a background, because the IR camera, like, it uses like thermal to figure out where you are, and someone made an
Right.
OBS plugin for that. So I'm using that. You can see it's a little off, like wherever you can see like a fuzzy line around me.
Yeah.
That's because it needs to be warm before it for where it finds the boundary. It's like thermal based, so it's pretty cool.
Yeah.
But that does mean I have like 100 things have to start up when my machine reboots.
No worries. We are still just chatting away, and folks are having fun with all the teams and other things. And yeah, honestly, like we have lived like such a weird times. Like I remember like using my iPhone camera for a while and like GoPro for a while. Like you're right, like good cameras were hard to find at some point. And while you're gone, like we were talking about some things that I had no idea about. So protobuf isn't one thing, is it? Like or the like you talked about not using generics, but Avro is something Fulschnabel is talking about. It's like a protobuf kind, like kind as in like type system is what you're talking about. You define a schema that describes
No,
a binary
I
format.
think like we've seen different RPC systems sort of tend to have their preferred serialization format. So I forget now, but like Apache Avro is a serialization deserialization format, right?
Oh, I see.
We've seen other things like Microsoft, in fact, has their own proprietary one called Bond. And then we've seen stuff like Thrift.
Wow.
Twitter
I
had
never
one
knew.
called Finagle. But sort of, and we evaluated a bunch of these too before we decided, okay, what are we going to throw our weight behind for .NET, right? And we ended up picking gRPC. I will say there were technical merits too, but like sort of what I alluded to in the beginning of the stream, right? You want an RPC system that allows you to talk to as many folks as possible, right? So we wanted something that has a lot of supported languages, a lot of high performance implementations, right? And gRPC sort of was the sweet spot in what value we wanted customers to get.
Yeah. I did not know like there were so many ways to do binary serialization, deserialization. And I suppose like everyone can have their
Right.
own ways of doing it, but again, you got to go with like hitting the most customers wherever your customers find the most like confidence.
So yeah, we were in the middle of a demo. So let me try and pull some of that stuff back up. So actually, I think it might be a good time to transition to a couple more couple other demos just to show like the
please.
gamut of what is possible. How are we doing on time, Sam?
We're good. Yeah, take your time.
Okay, so
No, we are just glad like Windows came back for you so quickly. You were not stuck with like long update or
Yeah,
something.
I feel bad because I'm supposed to like put the best foot forward, but this is when you're at home you have one machine. This is my machine that has everything. Uh, I've
Yeah.
definitely had worse days when I was doing more, like I think the thing that John was talking about earlier, like iOS not supporting gRPC, when I was messing around with some of that stuff, having bad kernel builds or mismatched
Yeah.
Windows binaries, never fun thing to do.
No, don't apologize. Like this is what is real. Like this is our developer experience, and a lot of times it is kind of limping through a lot of tooling and other things.
So let's see, I will pull up another demo. So what I want to showcase now is, we spoke about the simple features, but I think what uh, makes gRPC like both powerful and usable for like real world applications is like the ecosystem of features that go around it, right? Some of the stuff I had in mind was like, how do you like deadlines and cancellations are a first class thing in gRPC, right? Because one of the things we hear about like distributed system is this notion of cascading failures, right? You have something fail and that retries and that creates the spike and your system eats itself up. So having features like that built into the framework, or at least like well supported by your implementation of the framework, make it easy, right? So things I want to
Oh, so
showcase are,
Saurabh, you haven't shared your screen yet.
oh right, yep, everything has to come back. So some of the things I wanted to showcase were deadlines and cancellations, then transient fault handling, right? And we can look at some of this code even if we don't run through examples, right? So we saw the hello world, but like when you make a request, you can also send a deadline, right? Uh, and if it doesn't find on the deadline, you'll get an RPC exception, right? It's like a simple example. Another thing I want to showcase is transient fault handling, right? Maybe if something fails, you want to try again, right? And we also have some like you know uh, back off policies. Like you obviously again, like spoke about those cascading failures. You need to have like a back off multiplier so that everything doesn't like uh, take down your system. So we have things like, oh, if you have an unavailable, we can retry, right? So I think it's initially 1 second. The next, so it can be, so the first failure would result in a retry anywhere between 0 and 1 seconds. The next time it's 1.5. So it'll result in a retry of anywhere between 1 and 1/2 second, and we keep doing that. The other one I was going to showcase is hedging, right? Hedging is sort of is an aggressive way of making calls. So rather than make a call to one service endpoint, you're going to be like, hey, I'm going to make a call to multiple service endpoints and give me the result from the first one that completed successfully. Um, and then there's also client side load balancing that I want right that I want to talk about. Uh, so let me do this. Let me show a demo on uh, like distributed tracing to show you how like gRPC is a good citizen in that. Like again, observability into what your services are doing is super important in diagnosing what goes wrong. And you also get to see some of the features in ASP.NET Core that we build upon. And then if we still have time after the distributed tracing demo, let's look at client-side load balancing.
Okay. No, this is exciting. The chat room has been talking about like how these things are really tricky to do by yourself. And I'm curious, like how all of this, like from an ASP.NET standpoint, like these are async and await, right? So how do you queue things up, and where does your cancellation token and how does that stuff work?
I mean, I'll hand wave a little bit, right? Like the like async await is just your consumption pattern, right? Things like obviously if we do say a deadline, right? There are two aspects to deadline. One is everywhere that it's propagated, right? You want the deadline to fire, but on the client too, you want it to fire. And in our own implementation, we have our own cancellation token sources that we can fire a cancellation token. So it's um, it's it's not a like a obvious answer, right? Like based on the kind of failure mode, it's very implementation dependent.
Mhm.
But the idea is we don't break any of the idioms. If you're used to async await working in a certain way, it'll continue working in that way.
Okay.
So I will pull up this application that I have. This is a trivia game that I've built, right? So we go ahead and click play trivia. Let's not click crash because we don't really want it to crash again. But let me enter a name and hit start. Enter my name. I get questions. Do you want to take a guess, Sam? You want to help me answer this trivia question?
Yeah. Don't tell me it's Google.
It isn't actually. The G in gRPC stands for gRPC, sort of a recursive acronym.
Ah.
And then, so what's not hard in computer science? I'm going to go with building a gRPC implementation because I've just shown you how easy it is. So,
Oh, nice.
right. And cool. We scored 2 out of 2. That was our game, right? Now that was fun. So let me go ahead, close this. And now let me show you what exactly happened, right? This is the sort of visibility that you may need. So I have distributed tracing set up using OpenTelemetry. .NET has been working hard with the OpenTelemetry community. We're adding support, and so I've used the OpenTelemetry SDK and the OpenTelemetry Zipkin exporter to the point where you see I'm able to generate these beautiful distributed traces. And so this was my Blazor circuit, and you can see I sent an RPC call to start the trivia game. And then I had a streaming call. Like when we were playing trivia, you notice how as soon as we answered, we got another question, right? That was
Mm-hmm.
like a BiDi streaming between the server and the client. So you can see that went on for about 30 seconds when we were deliberating. And then when the game was completed, as a client, I asked the server, okay, cool, what was my score, right? And you can see there's the trivia. So this is if I were to use OpenTelemetry terms, this is the span created for this operation. And because the underlying transport was HTTP, then HTTP client created the span, and then this was the received span on the server. So you get this like cool waterfall chart. You can also see that, like, say when I sent the start trivia operation, as measured from the client, it took about 230 milliseconds, right? But some of that was the overhead of the transport actually making the network latency of making the call. When measured from the server, it was about 78 milliseconds, right? And you can see the same thing for the long streaming call. We had 31 seconds here, like 31.544 and 31.534. So, okay.
I have questions, and then so does the chat room. Like,
All
how
right.
how do you enable this?
Okay, so what I'm doing is I'm running a local instance of Zipkin, but I guess that's not really the interesting bit, right? You will have Zipkin running somewhere, you have an ingestion endpoint, and now you need to configure your app to say, hey, app, go take your distributed traces and spit it out to this ingestion endpoint. So why don't we take a look at the code? I guess that's what everyone's clamoring for, right?
Yeah.
Give me 1 second. I had all windows opened and ready to go, and now clearly nothing is open. So
It's real. Is Zipkin a managed service on Azure?
I think there's something in the Azure gallery. I know that I don't know if we have a host. So the observability service for Azure is Azure Application Insights, and it does support distributed tracing, right? So I'm showing you the Zipkin view, but we have very similar views in Azure Application Insights. So I mean, one of the questions I'd ask is there anything in particular, like a feature gap, that uh, you have an issue with, which makes uh, like application insights like untenable? Because we also do have, as the industry standardizing on OpenTelemetry for distributed tracing, we also do have an Azure exporter for OpenTelemetry, right? So you can still use OpenTelemetry and send that into application insights.
Yeah.
Okay. So let me show you how I've instrumented. So, one of the things I can show you again is, this is, we saw the RPC calls, we saw the start trivia, we saw the play trivia, which was like a stream of questions and answers, right? And then we saw the trivia score, which is again a unary call. So, and we saw this in the distributed trace. We saw all the RPC calls show up. These are all the messages. But let's see the fun part on how we actually hooked up OpenTelemetry, right? So let me go to my startup. And I added OpenTelemetry tracing, right? And then
no like NuGet packages required.
Oh, I did need that, yeah. So let's look at what I've added. So
Oh, I see. Okay, there we go.
Right. So I needed the exporter. So sort of the way OpenTelemetry is, you'll need the API, the SDK, and then an exporter, right? And usually, like if I just have a reference to the exporter will also have a reference to the SDK and the API. But if I'm like drawing out like boxes and lines diagram, those are the components. And then you have instrumentation packages for each of the libraries that you want instrumented, right? So I'm instrumenting ASP.NET Core and HTTP. Oh, and this is on the server. On the client, I've also instrumented the gRPC call. So you'll see I also have the gRPC instrumentation package, right? And then if you go look at my startup on my client, same thing. So I add ASP.NET Core, HTTP client, gRPC implementation. Normally in production, you probably don't want to always on sampler. You'll have like some sort of sampling strategy. And then the only bit for Zipkin you have to add is, hey, this is my ingestion endpoint, right? And I have that configured. I have that in config. I'm passing it in via an environment variable. And so it's getting, that's how it's sending it to that Zipkin instance that we were looking at.
So in any of your endpoints, like, did you have arguments? Like how were you passing in the answers to the trivia questions?
Okay, so I assume you're just asking a gRPC question and not a distributed tracing question, right?
No. Because I mean, the chat room was asking about some of the like protobuf fields being optional
So,
or not.
Yeah. So just one of the things I want to point out is like when we go here,
go
I do want to point out like this RPC method, the RPC service name, like all that stuff isn't something that you have to instrument on a per call basis. Like given that the library is OpenTelemetry aware, you get all this for free. Like this is really the extent of the setup I had to do to get all this working. I just wanted to like close the loop on that.
Yeah, no, this is nice.
And I will get to the optional question in a second. So I see John saying using SEQ and Zipkin. So yeah, I did want to show something compelling about this demo, right? So we looked at, say, this call, and suppose I want more visibility, right, into this call. Let me go back. Actually, you see the trace ID here?
Mm-hmm.
What I can do is I can use this trace ID, assuming I've set up logging correctly. Oh my God, I cannot seem to copy this for the life of me. Okay. Assuming you've set up your logging correctly, what you may want to do is, okay, this is cool. This gives me that waterfall view of what's happening. But if I want more visibility into my services, into what's happening, you can use this trace ID, and what we do in ASP.NET Core right now is we stamp all your logs with the relevant trace ID. So if you wanted like, hey, this took 30 seconds. I wasn't expecting it to take 30 seconds. Can I find out what was happening? Sure, you can. You just need to open your logging backend. In my case, that was SEQ. And then, you'd see something like, so that was one. So I'd say, hey, find everything with this trace ID. And you'll see all my logs had been annotated, right? So you see, these are all the logs in like temporal order that had this trace ID, and this spans both the front end and the back end, right? You can see like it's sending the request here and on the back end. So this is the entire, and like in my case, I'm using SEQ, but if you were doing logging, right, you would have this stuff annotated on your logs.
Interesting. Yeah. I'm learning so many new things here. What is Serilog with SEQ?
Serilog is just a logging library,
I
and
see.
SEQ is the tool I'm using right now. So use a logging library, and you say, hey, I want to, the sync is SEQ, and like, you know, I like this. This is my tool of choice for local development, and you know, obviously, it's sort of, to me, it's like, you know, you might be using Elasticsearch or something like that, but you want like structured logging, and you want to be able to do things like search on fields in the structured logs. So this is super powerful, right? Like there's only so much you can contextual information you can get from like formatted text logs. So console logs have like this limited, after which they're sort of hard to parse, right?
Yeah, makes sense. All right. So, do you want to go back to
Right.
some of the gRPC stuff?
Yeah. So let's go back and look at the proto file. Okay. So we sort of did 3 calls. We have a start trivia where you send your player name, and then you get a game ID, right? And this is because this is stateful, right? Like we need to preserve some state on the server while the call is still going on. And then when we start playing games, there's a stream of trivia questions and answers. And remember the bit where I said, like, because it's a full BiDi stream, there's no temporal relationship, right? So the way it works in this case is when you start, you don't actually send anything. Like once you've established the call, you wait for the server to send you a question. And you wait until you've answered that question, until the server sends you once you've answered that question, the server sends you another question, right? And I'm sort of actually running this in one player mode. This is actually set up as a multiplayer game. So you actually wait until all players have answered that question, and then everyone receives the next question at the same time, right? And then once you're done, you sort of here the trivia session. So you what was it? Here, yeah, you ask for your trivia score, and you have to supply your name and which game you were in, right? Because your players can play multiple games, and then you return the score. It's not the fanciest app in the world. It's just a simple app that shows a lot of features using streaming and things like that. So in my case, I'm not really using any. I'm not using any like optional fields, but you'll see a couple of interesting things. One is when you see the streaming, like what a BiDi stream looks like, you will see that the RPC contract only has one message type, and if it's a stream, it can be a stream of that message type. This isn't some sort of like discriminated union of types, or it doesn't even have like multiple parameters. That's sort of the contract enforce. You only have one message type here, right? And if it's a stream, it'll just be a stream of that message type. And then you'll see some of the things, the other parts of protobuf that we're using. When we look at what a question looks like, a question has like the text of the question ID, and then it has a repeated string of answers, right? That's how we have multiple choices expressed. So we're using like different parts of like the protobuf spec.
I have a lot of questions, but let's hold off and maybe let's go to something you said before. Like how do you keep track? Like how do you keep state?
This is a demo. I don't do I keep state in memory, so this
I
isn't
see.
meant to be.
No,
Right,
no, that's fine. Yeah, I was just curious.
but if you were to deploy this as an app, you would have you'd have some sort of like distributed state store, maybe back it in Redis or something,
Right.
and then you can have multiple people. And then one of the things that is maybe sort of orthogonal in this demo, but I kind of want to point out, right, because, and this is back to the original point where this is just another app model in the ASP.NET tool belt, right? You can mix and match, right? gRPC may be the right candidate for you. Maybe SignalR is, right? So one of the things that I didn't showcase is, so remember we connected the front end and we were playing the trivia. That was the trivia client, right? But if I connected the server, right, and let me see if I can get this working. And then this is actually the server, and the server has this thing where it uses SignalR, so I can see the score in real time. So, right, and so these are multiple app models, SignalR, gRPC, all working on the same data model, right? So let's say I am Bob who's playing this game. Like as I answer questions, you can see, A played earlier. Looks like I had some JavaScript bug there. A score shows up now, but you can see a real-time dashboard of Bob's stuff, even though the client doesn't know about it yet, because it's the same data model, but I can use it across same data, but I can use it across my different app models, right? And let's say Bob doesn't know this answer. You can see Bob's score, Bob on the chart, so you can do all these sorts of cool things.
Yeah, that is very interesting. The way you put it, these are all things for you to use in your ASP.NET tool belt.
Right, and so if we're looking at the trivia server, let's go look at startup, right? So I showed you we're using OpenTelemetry. We obviously, this app also has Razor pages, that was the one serving up the UI, right, for our JavaScript app. And then we have SignalR as well. And if we look at what we're mapping Razor pages, we're mapping our SignalR hub. This is the score hub that's giving us the live dashboard updates. And then we have the gRPC service as well.
So, dumb question here, sort of. gRPC by itself, that's not real time, right? Or can it do real time?
So I love the question because sort of I'm going to go on a tangent, but
Please.
I actually studied embedded systems, so I love how I love the textbook definition for real time is that there is the finite upper bound on when an operation completes, right? And I'm being pedantic, but sort of if you tell me if I tell you I have a real time system and my finite upper bound is 24 hours, that is still considered real time. So I assume you didn't mean that, and you meant is it perceptibly fast enough that it looks like I'm not waiting? And the answer to that is yes, right? You could use it for some things that you use SignalR for, but we're building upon things like TCP and stuff like that. So it's not real time in the embedded system real time sense, but can you build something that's responsive and seems perceptibly fast? Yeah, absolutely.
Interesting. No, that's a good way of putting it. As I keep so John Miller had the comment that gRPC will probably become the de facto standard for microservice communications, and that's the thing that I hear most people using gRPC for, service to service. Maybe it's behind your firewalls. It's within your data farm. But when it comes to just creating a simple dashboard or something in real time that you're wanting to pull off, I see most people going to SignalR. But you're saying if you architect things right and if the contracts are right, then you could also pull it off with gRPC.
Or use a combination. In this example that I showed you, right? You may have the client talk to the server using gRPC because you want that contract. But maybe the score dashboard is a public component that anyone can hit, or I viewed it from my browser, right? It would have been hard to do it from my browser using gRPC. So yeah, use SignalR for that. Yeah, we give you options, right? And I think that's always a good place to be in, rather than like being overly prescriptive, saying you have to use gRPC for everything or have to use Signal for everything. This is a much better world to be in.
Yeah, no, it makes sense. And John Muir is also pointing out like the communications are very much optimized because it is protobuf.
Right.
Yeah. Cool.
I mean, I will say to some extent, some of that is like a synthetic benchmark. Like, in our example, we were updating the score, right? The honest truth is, like, if you're sending a score, it's one long at best. So the benefits of serialization and like data savings over the wire may not be that significant. You may want to use uh, other factors in your decision on like why you go one way or the other, right? Like I think the protobuf or message pack is far more compact than JSON may mean you're making other trade-offs. So just don't pick only that number.
Yeah. Okay. Any more things you wanted to show?
Yeah, so I
With your
think
demos?
one thing that would be cool to show would be, you spoke about gRPC would be a good candidate for service-to-service communication inside my inside my service boundary, right? I want my front end talking to my back end. So I actually want to show some of the, more I would say production grade features in gRPC. And I think client-side load balancing is a very interesting one, right? Because we have this affinity problem in HTTP2. Like load balancing on HTTP1 was reasonably easy because you for the most part, pipelining isn't a real thing. So if you have two concurrent requests, they're actually going on two separate TCP connections, right? So you basically had a connection pool to choose from. And if you were talking from your front end to your back end, you would just go down that list, pick from different connections. With HTTP2, you have this, I'd say, issue where you have it's a multiplexed connection, right? You have multiple streams. So you have multiple HTTP requests going over the same connection. So like naively or like a mistake that I've seen a lot of people do is when they try to like do naive load balancing, they end up making all their requests on the same connection, right? Uh, and so, again, this is something like people shouldn't have to know, right? Like, hey, I'm trying to make an RPC call. I don't care about the TCP connection. Just give me the right performant behavior, right? So I do want to show you a demo using gRPC with client-side load balancing in the context of Kubernetes, right? Because that's sort of how most people will be using it. So
Okay.
let me see if my stuff is still running.
I gotta say, the last hour or so, like I'm blown away because I don't live in the hardcore ASP.NET world, and like just being with all you smart people, like I'm learning things that I didn't even know existed. So I'm really enjoying. John Muller was talking about something called Quick,
Right.
which again I didn't know anything about. So this is
Yeah,
fun stuff.
Quick is the underlying I say layer 4, like the OSI layers layer 4 transport for HTTP3. Yeah, Quick will solve some of these problems, but I think the idea is if you're doing RPC, you shouldn't be expected to know this, right? Like like Sam, you shouldn't have to apologize for saying I hadn't heard of Quick before. That's the goal. You're just trying to call a method in another process. You don't care
Yeah.
if it's what protocol is used at what OSI layer. And if we're doing our jobs right, you can be successful at building apps not having to know that, right?
Yeah.
So I'm gonna cheat a little bit here because I deployed this app to a cluster which is in my corporate subscription, and then there are firewall rules that don't allow me to access it publicly. So I'm not going to fight that, and what I'm going to do is I'm just going to port forward traffic instead. So just some context on what I have. I have an application that has both a front end and a back end, right? You see there's one replica of the front end, and there are three replicas of or is that four? Four replicas of the back end, right? And excuse me, I have a simple API where the front end calls the back end is actually the Blazor templated app we have, which is the weather API. So let me just go ahead. I sort of cheated a little bit where I've gone ahead and just port forwarded the traffic, but that's sort of almost irrelevant to the demo, right? And now I want to be able to make a call, right? And so we have we have a couple of like load balancing schemes and resolvers. So there are two things I want to talk about. One is I want to talk about resolvers, right? My front end needs to talk to my back end, but it needs to know how many instances of the back end there are. It has to resolve all the instances, right? And not just how many, it needs to know where each one of those are situated. Then it has a strategy, a load balancing strategy that says, okay, of these instances, which one do I go talk to? Right? So like the idiomatic Kubernetes practice is hopefully I have this somewhere here. Sorry,
And the reason why it matters, like which exact endpoint or backend you talk to, is because like it's like sensitive, like weather data that you're trying to get. So the location is important.
No, no, actually, that wasn't the point. I wasn't trying to say this is a stateful app, but you're totally right. If it was like if there's some sort of state, then that matters. I think I was talking more in terms of if you want to load balance, right? You need to know who are the three people you load balance between, right?
I see.
So for
Okay.
that, first you got to resolve everyone.
Yep.
So then you have your deployment template that looks something like this, right? Like you have a front end, you have a front end container, and then you have a back end. You have a back end container, and then you may do something like, hey, the number of replicas is 2, right? But now your service, your front end service needs to know, oh, there are 2 replicas, right? So how does it do that? So the way this works in Kubernetes is it works via DNS resolution. So let's do some fun thing here. Let us do.
And while you're doing that, sort of just real quick, I don't know if John Muller has to run, but John, thank you so much for hanging out with us. You have been super insightful. I've learned a bunch of things from you. And John is right. Like so much of this is like free and it's just like built in. Like he's talking about the open telemetry, HTTP3, all hidden behind minimal APIs. And that was the point, John, to kind of highlight all of the cool things that ASP.NET can do with performance and speed. And that's all a reality today. So thank you, John. Thanks for your comment and thanks for hanging out with us.
Right, so what I did is I SSH'd, well, not quite, but I'm execing into my front end pod, right? So the way the front end would discover the back end is it's via DNS resolution. So for folks who are familiar with Dig, that's how you look up like DNS records. For those who are not, like the response will kind of make sense. And so you will see that when so some more context here. This is how you communicate between services in Kubernetes, right? So actually, what I probably should have, do I have curl here? Oh, shoot. I do apt install curl. Okay. This is, we're going off script now, so hopefully things work.
That's all good.
Okay, so,
and while you're doing that, I'm just going to quickly say one quick thing here is in about 4 to 10 minutes, we're going to do the drawing on the prizes. So folks, if you have not, go ahead and fill up that quick little form so you can be in the drawing to win some prizes.
Oops, looks like okay, let's do this again. So the way like my front end would talk to my back end is I'm just doing like a curl. I'll say curl HTTP, right? And then you use the service name, the Kubernetes namespace. So this is the backend service in the default namespace, and then .svc. I don't know if you can hear that, Sam. One of my neighbors decided to pull out their leaf blower right about now. So
that's all right. It happens to me all the time.
So yeah, so right. Oh, okay, this is probably a bad example because I'm using gRPC 2 over HTTP. I had the wrong protocol and it's like binary output, whatever. But this is sort of how you talk to your backend, right? You use the service name. But how do you find all the instances of the back, right? Because if you just do HTTP and you just make an HTTP, you use HTTP client, make a call. HTTP client will do a DNS resolution. It'll pick one of those instances, and then you'll just be using that, right? So what I'm going to do is I'm going to run dig. Dig tells me, like, gets me all the DNS records. So you'll see I have 4 A records here, right? And these give me the IP addresses of each of these backends, right? And so if I go back to my app, you'll see it's a Blazor app which has a little more information annotated. Shoot, where was it? It was here. So you can see these are the sub channels I found. So it actually resolved all this. So the way you do it is, it might be easier for me to just show you in here instead of looking at the code. We'll look at a DNS resolver, right? So the same thing. You've seen this pattern, gRPC channel for address. We created a channel, right? But rather than saying like HTTP and giving the host name, we use this convention where you do DNS colon. You'll see there's a triple slash, and then you give the DNS name. So this would be your FQDN, right? And then you can, so that way now your channel has resolved all these sub channels. And then when you configure like a load balancer, right? You would oh shoot, I didn't mean to do that. You would specify. Oops, let me go back here. Now that your channel has all this resolved, you also have to specify like a load balancer saying which of these sub channels you resolve to, and that's that's what we've done here. And right, so now let me show you one more thing in terms of like how this, why this is so powerful and so easy to use. So let me jump in here. I'm only doing this because I sort of forgot the kubectl thing to scale my services, so I'm gonna kind of do it from the UI right now if this decides to load eventually.
John Morris saying Kubernetes arcades. Hardcore is above my head. That's true for a lot of people. Like I've started
Right.
scratching a little bit, but yeah, I mean, a lot of the communications can sometimes, like, it takes time to understand, sit down and understand.
Totally. But I mean, it's also, that's sort of the challenge, right? Like, okay, client-side load balance is cool, but you wouldn't use it unless you're like in this situation in a cluster. So
Yep.
I apologize for the tangential complexity, but it's sort of needed to like showcase this, right? So
No,
what I'm going to do is I'm
absolutely,
going to go to
yeah.
my backend
real.
service, and I'm just going to right-click here, say scale. And we had 4 instances. Let's scale this down. Let's scale it up to like 5. I was going to pick a bigger number, but then I realized my cluster is highly underpowered, so I don't want other failures, right?
Okay,
And
wait. What did you just do? You
sorry.
hit scale as a command?
Yeah. So in Kubernetes, right, you can like elastic scale, right? The whole point is you describe infrastructure as code so that you can scale out. So
But like you updated the YAML file with 5, right? Or was that like a separate command?
well, I used the GUI to do that, but it is
I
effectively
see.
the same thing.
Okay.
Let's do this. Like, it might be easier to see here. I've just done kubectl get parts -w, right? So this might make it easier to see. Oh, okay. Now you can see everything.
Yep.
And let me scale this down to 0, actually.
Mm-hmm.
You see how all of
Yeah.
these are terminating?
Yeah.
Right? And if we also go back into our app, so it is idle right now, but if you see transient failure, there are no like available subchannels, right?
Yeah.
And we would also see the same thing if I went in here and I did a DNS resolution, right? I only get like no A records, right? And now let us scale this back up to, let's say, 4 instances, right?
Yeah.
And let's make another, let's go look at DNS here. Oh, there you go. See, I have 4 IPs. I don't know if the services are up yet. Oh, they already came up.
Yeah.
And you see, like I have the DNS records for it too. So this stuff can change on you, right? And as an app developer, you don't have to handle the complexity, do the DNS. So like this is like stuff that's first class built into gRPC. And if we go back to my like sample app, you can see that, oh wow, I have all these sub channels to pick from, right? So if I did want to like if I changed my strategy to like round robin.
Oh, you even have a UI for that.
Yeah,
This is
I
nice.
will in a second. I'll point out to where the source lives. I'll give a huge shout out to like James Newton King.
Oh, I see.
Like he has comprehensive samples for everything gRPC.
And it is funny that he started off with with Newtonsoft.
So yeah, so you see now I have all these subchannels available, and I can keep. You see, like I'm round robining, so you just keep looking at where the data was loaded from, right?
Mhm.
And I'm going down the list. And so I showed you all this complexity, but if you don't need to know how any of this stuff works, you just have to say, I may have multiple instance like backend replicas, and I just want to round robin through, and like we make all this just magically work.
Yeah, this is amazing. This is amazing. You're making our brains melt.
So yeah, so I think that was the last demo I wanted to show.
Yeah.
Or the few other things that we didn't. A couple of things. There are docs for all of this, but you know, I showed you the DNS resolver. You can have static resolvers. You can write your own custom resolvers, and even for load balancing, I showed you pick first and round robin. You can come up with your own strategy, right? You can pick, and there are docs on how to implement stuff like that. And I'm just looking. Yeah, we already spoke about like hedging, transient fault handling, and I think we looked at deadlines, right?
Yeah.
We started
Yeah,
the
we did.
sample. So
Yes.
so I hope I've covered like right from the basics of, let's get started, hello world, gRPC, all the way to show me these like cool features that I will need when I'm running a production grade app in a Kubernetes cluster. So I hope we
Yeah.
covered the 0-200 everything.
You absolutely did. And in the chat room, Anup CM is saying just the right time when I was about to start my first gRPC app. So yeah, you're welcome. And John Muller is happy. All right. So Sourabh, anything more? If you don't have anything more to show, let us know, and then I can bring your
I think
stuff down.
I'm sure there's more stuff to show. I'm going to give my throat a break. It's been a long day of talking. So
I bet, and clearly your passion shows. You can talk about this all day. But let's see, our other host, Ed Charbonneau, who's more of the ASP.NET mastermind, he's lurking in the back room, so I can bring him on, Ed, if you're ready. Yeah, there you go. Ed, this stuff is a little bit beyond me, but this is super cool. Did you have any questions for Sourabh? You're on mute, sir. Oh, we have
Of course, I forgot to unmute myself. I said, hello, Sourabh and Sam. Yeah, this is all new to me. I learned a lot today. I don't really have any questions or way to expand on this. You've delivered way more than I expected, so thank you for that.
Yeah, Sourabh, what time is it? It's it's right past like 12:30 for you, so lunchtime for you, right?
Right, that's my next thing. Go and fix some lunch. So.
All right, so thank you so very much for doing this. And folks in the chat room, hang out with me and Ed for just a little bit longer because our social media, our magicians, they're actually behind the scenes and they have pulled some winners. But before we do that, Sourabh, once again, thank you so much. We appreciate everything that you and the team does to make gRPC like a first-class citizen within ASP.NET. So thank you.
Yeah,
thank you,
really
gentlemen.
Cool.
It was fun being on the show, and for all the folks in the chat, try it out. Like gRPC is ready to use, and we really love to get your feedback. You can find us the GitHubs. You know where to find the repos. You know where to find the docs. It's like one Google search away. So try it out. Let us know what you think, or if you have any requests or issues.
Absolutely, well said. And you have Saurav's Twitter handle there. You know where to find him. So Sourav, we're going to let you go. So thank you again so much.
All right, bye, folks.
Right.
Bye. Thanks again.
All right. So our the magicians behind the scenes. You see me and Ed and our faces, but there are two gorgeous ladies who are actually up late into the night supporting us for our streams. They're both actually in Sofia, Bulgaria. That's Ivana and Cindy. And they, what time is it? Let me check. It's like 10:30.
Yeah, that's a full day for them, like a 12-hour day.
Yeah, but they have pulled, they do the random number generators, and they go through a list of all of the people who have filled up the form. So we're not going to waste your time kind of going through that. They've already pulled the winners, and drum rolls, if you want to add, I can pull one winner name at a time.
All right. Let's do it. We'll scroll them at the bottom when you're done, Sam, so
All right.
they're missed. They can see it.
All right. So first winner is, let's see, John Muller. John Muller. Is that the John Muller? Yeah, that is your name. So welcome, and you're amazing. Thanks for hanging out with us. That is you, John Muller. Okay, so there you go. You are the first winner. You're the first winner. See, luck favors the folks who hang out with us longer, because then you show up more in the forum. And
I like the screen name on this one. This is a fun one. So the next winner is Sean Block, and the screen name here is Quad Vente Soy. If you're still around, you are a winner.
Yeah, and we see Quad Vente Soy on other streams. And Ed, your mic is really jacked up, which is fine. You have a
jacked
voice.
Up. Is it loud or quiet? Or
like loud?
Oh, okay.
Which is good. You have a nice soothing voice. John Muller is there. The tiger is still there. And hold on. Speaking of the tiger, hold on. That's our third winner, Chris Siminski, if I'm saying your name right. The tiger. Congratulations, you folks. Golf claps for you. The three of you are winners. Winners for the Amazon gift cards, and winners in our books for hanging out with us and supporting us all through. So big thank you to all of you.
And give us a little bit of time for those gift cards to get emailed out. It takes us a few days to process all that, so it won't hit your inbox today. Don't freak out. It'll be there probably by the end of the week, though. So
the tiger is still here. So is John Muller. So congratulations, folks. And if I may, these are the two wonderful ladies who support us. That's Ivana Dimitrova, and let's see if I can find the other one. That's Raptane. So these are Cindy Voskova. So these are the two who support us all throughout their days, and it's a long night, so way past their dinner and time to get maybe grab a drink.
Absolutely fantastic, folks.
All right, so Ed, this was interesting and enlightening for me. I live on the kind of bleeding edge of client side. I had no idea you could do this kind of stuff with ASP.NET. On the back end. This is amazing.
This is how the sausage is made.
Yeah,
this is the way it's done.
Clearly.
Yeah, there's so much tech in the ASP.NET stack that I can't possibly know all of it, let alone probably a fraction of it. So while I've dabbled with web APIs and taken a look at SignalR and gRPC, I've barely scratched the surface.
Yeah, no, this is amazing, and just the performance benefits of what you get, and like some of the minimal APIs where we started. This is amazing to kind of put the backend together. That's rock solid, and then you can serve up any client across any platforms. Okay,
and that's super lucky today too to have some of the ASP.NET folks join us. So we had. Who did we have on in chat room earlier again?
We had Damien
Edwards
and David Fowler was around.
David Fowler.
A lot of the .NET team, and then Sourabh is part of the .NET team as well.
Yeah, absolutely.
And
we had David Pine was here too, and he's not part of the ASP.NET team, but he's part of the Docs team.
He is very much into ASP.NET. We're big into chickens. Yeah, time to say hi to the lovely chickens. And let's see, is anybody on for us to raid?
I think that might have been. Go ahead and look, Sam. But
queued up.
If we don't have a person to raid. I think that might have been what Cindy was alluding to. It's time to visit the chickens.
Oh, I see. Okay. Oh,
So
our
we-
chicken life. Oh, we love this.
So
love
I can
this. Yeah,
queue
let's
us
do
up
it.
for a chicken raid.
Let's do it. Yeah, let's do it.
So if we
yeah,
do-
once again, chat room, everyone in it, thank you so very much. We hope you've learned some things as we have, and it's amazing to see all of this stuff that's free and ready to use right now.
And we're getting ready for the obligatory raid of Our Chicken Life, which is literally what it sounds like. And for some reason, I think, oh, there goes my raid, is ready. We have 122 souls ready to go visit the chicken stream. Are you ready, Sam?
Yeah, I am.
Let's
So
see. Take care,
signing
everybody.
out. Thank you. We'll see you soon.
Bye, y'all. We are chicken.
Okay. And broadcast?
Yep.